Thank you all for coming to Hotston now, I guess is the new name. It used to be Hotlanta, but it's Hotston now. My name's Tony Williams. I'm with the Army Applications Lab here at Futures Command. New to the team, pretty excited. I run the Corporate Ventures and Technology Due Diligence Group. So on behalf of General Rainey and Dr. Purley, at the lab, I want to welcome you all here. This is a pretty big deal for all of us, especially those of us like me that have kind of spent 35 years on both sides of this as a former Army officer and OSD action officer, and then about 15 years as a corporate development guy on the big industry side. So this is an exciting time for us. This is something I had always hoped as a young engineering officer that we would see. Some kind of big movement in technology transfer that actually gets the Army what it needs faster. So I'm excited to say that that's what we're all about, and that's what most of you guys know already. We're looking for solutions to problems that we've identified, basically. And that's it as the modernization continues. So I want to introduce our commanding general, General Rainey, here today. And I want you guys to know how big of a deal it is to have a 4-star as your CG. That means stuff actually happens. I'm here to tell you that means stuff actually happens. And reading through his bio, I just told him a minute ago, long list of Army accomplishments, of course, but the best is his dog Sherman, which I was hoping was still alive, sir, when we were going to introduce you today. Would have been a little embarrassing. So just a couple of admin items first, sir. If I could just tell these folks, bathrooms are on the second floor. Ingress, egress, left and right. I think you know that. I'll be your MC through the day, and we'll have a little bit more for you here in a minute. General Rainey was nice enough to stop by. He's got a busy day, and without any further ado, sir.
No, that's a very great and short introduction, so thank you. Casey, to you and your team, thanks for, as always, for putting this on. And thanks, everybody, for making time. You know, everybody's busy. Time's money. We all got families, stress. So I always like to start off thanking everybody for sharing some of their time with me. So thank you. Okay, this is a pretty eclectic group, and I got 30 minutes. So I'm going to kind of hit a couple different topics and then take some questions, and hopefully some part of it will be interesting to everybody. I'm going to talk about persistent transformation, right? So the United States Army, the United States military, I believe needs to transform, given the realities of what's going on in the world now, and more importantly, the rate of change and the requirement. I believe we're the best army in the world right now. I believe we're the best military in the world. I believe we would prevail in a war with anybody. I don't think anybody would win a war between two nuclear-equipped superpowers, right? We're going to prevail, but it's not a war that anybody wants to fight. So this is really, because people have different ethical positions when it comes to things like AI and the ethical use, robots. What I tell people is one thing we all can share in common is not wanting to have a war, right? So I think there's plenty of room to work together wherever you come from on that, because we do not want to have a war with China or Russia. We want to deter that, right? So to do that, we got to continue to maintain our advantages. And we got some challenges, but there's more opportunities than challenges. I would offer that in the United States of America, if you're familiar with the instruments, and now start way at the strategic theoretical level and end up talking about rifle platoons with robots in them, which I know you're more interested in. Diplomatic, military, and economic power, right? The instruments of national power, Machiavelli. Somewhere since I've been in the Army, we added information to that. Makes a better acronym. Now you can say DIME. I believe in the United States we have the potential to add T, technology, to that at that level. I mean, our diplomatic, economic, military, informational power, the United States has all the positional advantage largely because of capitalism and entrepreneurism, we have the ability to turn technology into an instrument of national power. It would be good if we could stop the Chinese from stealing all of your stuff. That would be helpful for us to gain and maintain an advantage. But we got to do a lot of work. We're too slow. I'm very critical of myself. As the commander of AFC, I have great teammates. The thing I'm not doing as well as I would like to, I call closing the acquisition kill chain, right? We come out to you, we ask you to do things, you do it, you show it to us, and we should buy that. So I'm working really hard on that. It's very complicated, no excuses, but I aspire to, if we ask you to do something or we put out a proposal and you have the best product or one of the best products, that should translate to some kind of, momentum. And we do it good in some cases, but fast is relevant. So I have one slide here, two. So let me start with persistent or consistent transformation and the requirement to do that. And I think about it, it's three. Everybody can see the slide except for me. I can only see half of each one. And I just use them to make sure I don't ramble. But let me start with the middle. Everybody's familiar with Army modernization. We got our modernization priorities, the 30+4 programs, right? IRCA, IFPIC, FLRA, MPF, big major programs. I refer to that as deliberate modernization. If you understand how the government works and how the Army works and how Congress works, you kind of got a FIDEP, a POM, like a 5-year process. You're supposed to be accountable and planning. And there's a total Army analysis process that determines the force structure to go with that fiscal. So deliberate modernization. And really, once you do that, you give up a lot of flexibility. You can still maneuver in that space, but you kind of got to, Congress, the taxpayers really expect us to be able to say what we're going to be doing for about the next 5 years and then be held accountable to that. So that's, I refer to as deliberate modernization. And we're in a pretty good place in the Army. We've done a good job of not moving the goalposts. Some of our epic failures have been when we wrote a requirement document and then kept changing it. So we kind of figured out not to do that. And the other one is we kept changing our priorities. So we've been pretty consistent in that middle space that has been working pretty well. What we are not doing as well is a couple other things. We need to go out further into the future, not to get it right. Nobody's going to predict the future, but to not get it really, really wrong and do some serious thinking about what the future of warfare is. I personally believe there's some gigantic changes in the way militaries are going to fight if you get out into the next decade. The battlefield's just getting so lethal, so fast. The defense gets stronger and stronger. The offense gets more and more costly. Our enemies are getting better. The world's getting more dangerous. That's a whole nother talk. So we need to figure out how we're going to fight. What's that environment going to look like? How are we going to fight out there and determine the critical required capabilities that we need so we can figure out the things we know we're going to need to do that are not possible yet but are not ridiculous, and start driving S&T and R&D into that second and third FIDEP, 30 to 35, 35 to 40. And when I say 2040 in most audiences, probably this one included, people's mental screensaver just, you can just watch them shift over to ESPN mentally or something. But 2040 is not as far as you think. If you want an Army in 2040, you got to be fully fielding it by 2035, and that's ambitious, a 5-year fielding. And if you're going to field something in 35, it needs to actually exist, prototype, low-rate production, 30, 31, 32. And we just committed money through 29. So 2040, if you're in the S&T, R&D, big idea business, we're like in an 18, 24, 36-month period of somebody's going to win that intellectual fight that's going to translate to the best military in the world about 2035, 2040. So that's the second one. The one I think is most interesting to you all, this crowd, because this is where human-machine integration falls, in my view, is inside 2 years. Not rapid development. I'm not talking about inventing something new in 2 years, but I'm talking about rapid acquisition. The ability inside 2 years to see something that is happening in the world on the battlefield, a technology breakthrough, and the ability to translate that into actual capability in a formation. I think we got to be able to do that inside 18 to 24 months. And and this is like crazy talk, but we got to be able to do this. And Mr. Bush, our ASOL, is with me on this, and the chief and the secretary. So while we do that deliberate modernization, if you're going to buy a new tank or a helicopter, you probably ought to go super fast, right? You can't go slow, but deliberate is a good word if you're buying $1 billion program. And we got to do some deep thinking about the future and start driving S&T and R&D. But inside 2 years, we absolutely have to develop the ability to rapidly acquire things that exist. So it's either something that exists that you want, or you can see it, all the pieces exist, and you just need to rapidly integrate it and deliver it. So things that fall into, for example, loitering munitions, a quality system of UAS at the company level, ground-based rockets for our infantry and soft formations, ground-based missiles. Infantry can kill tanks at range. One of the very fascinating phenomenon, I see Sean Jenkins and some other legendary infantrymen in this crowd. I'm sure he's not the only one. We all grew up in light infantry formations that fought 3 to 5 kilometers, right? That's 25, 30 now. You can absolutely sense 25, 30 easy. And if we can put the ability to strike at that range inside our light formations, right? Because the light infantry is awesome. The problem is they can't kill tanks, right? They can't survive. You got to have heavy and light. Well, maybe the answer to contested logistics isn't figuring out how to move 90-ton tanks around. Maybe it's how to take your already really mobile, agile light infantry formations and just make them as survivable and as lethal as a good armor formation. Now, you're still going to have to tuck them into restricted terrain. So those kind of 3 periods of time. And then there's some ASALT and some government folks listening. So I got one more. Can you go to that next one real quick? This is what is a dilemma that I will try and explain to you. Oh, there's a slide up there. Good. Okay, so now I can see. Here's what's interesting. When it comes to fiscal agility and requirements, this gets back to that, how does AFC do a better job? And I don't want to speak for DOD, but I'm very confident that the other services and DODs have the same closing the acquisition kill chain I have. But what's interesting is so if you think XY axis there, in 24, my understanding of what I want is pretty high. Like, I know what I want this year. I have almost no ability to move money, right? Like, don't anybody quote me on this. Everybody says, we don't have enough money. Money's tight, austere, fiscal. $185 billion is a lot of freaking money as a taxpayer. So I believe we have enough money, right? We got the money we got. The problem is really the agility and the ability to move it inside. I mean, don't get me wrong. We could always, use more. But so when I know what I want, I can't move money. Then you go out a little, like say, let's go out to 2030. I haven't even palmed there yet. I haven't committed resources, or 2029, the 5th year of the FIDEP. I haven't committed money yet. So I got a lot of fiscal agility. The problem is, holy crap, who the hell knows what, who the hell knows what I'm going to want in 29, right? Would anybody make a 3-year commitment to any piece of technology right now? Would you buy a phone if hey, buy this phone, you can't buy another one for 5 years? Nobody's going to do that. So where you lose clarity in your requirements is where you have your fiscal agility. So what we need to do, all of us in the government, is work on those two things. We got to figure out how to write a requirement that's specific enough for you to do something with, but not so specific that it's got a 1 or 2 year shelf life. And that's an ask I have for industry, is help us. When you get a crappy requirement document, come back. You know, that's one of the things that AAL is really designed to do, is to do that informal iteration. Or, you know, hey, I got your request for proposal. It's a piece of crap. I have no freaking idea what you know, what is this? It's 50 pages. I can't tell whether you want a truck or a cow, you know. I mean, like, we need to know that, right? Like be hard on us, okay? I'm sure that never happens in my organization, but I've heard that happens. But that's what we got to do. So it's absolutely necessary that we close that we can write a document that's far enough out where we can have the fiscal agility for it. So that's a big challenge. I want to share that with everybody in case anybody has any ideas or thoughts can help. Okay, that's the end of the slides. This is a robotics thing. I'm not a big fan of the term robotics. I kind of like the phraseology of human-machine integration. And that's what we're into. That's inside that 2-year priority for AFC, it's tied with fixing the network as mine and the chief's priorities, right? We got to figure out the future of the network, and we got to figure out human-machine integration. And a couple thoughts, and I'll shut up and take questions. Human-machine integrations. We are not trying to replace humans with robots, okay? We, the Army. That may or may not be a good idea in industry, I don't know. But a flaw in our approach to date, in my opinion, has been we've thought about this from a lens of what humans can we replace with robots. What I want to do when I say human-machine integration, is optimize the strengths and mitigate the weaknesses of both. So I have no vision of an autonomous robot formation or robots running around by themselves, right? And we don't want to buy a robot. I don't want to buy a robot to do a thing. We want to build and buy human-machine integrated formations. The number one thing to do is, I'm all for robots doing hard manual labor, especially if it's like this out or some of the places we've all been on the battlefield, right? But it's really about offloading risk. The priority is to offload risk from humans to machines. I personally, one of the things I say, no blood for first contact, I mean, we are all good enough. The technology exists. The next time men and women, we're in this uniform or in combat, we should not make first contact with the enemy with a human being. No more IED strikes. No more stumbling into minefields. No more coming over an IV line and losing a soldier because the enemy was over there, right? I mean, between the ISR, space-based, and other technology we have, and I'm all about fog and friction and rain and dark weather, but we should aspire to never again make first contact with a human being in our most valuable formations, rifle squads, tank platoons, those kind of things. So offload risk onto machines and optimize the humans for the things that machines are never going to do, ever, is values-based decision-making in incredibly complex situations. So a tank crew in a tank should be killing. They should be focused on finding and killing the enemy. Anything else that isn't that, let's try and offload that onto a machine. But we're not going to turn over the values-based ethical responsibilities involved of taking human life to a machine. I don't believe the United States is ever going to go that far down this path. So optimizing the two. So in one thing I've learned from hanging out with my friends and teammates down here in Austin and other places in industry is mid-viable product. You got to go fast. As soon as we can do something that is more value than it is cost, I want to roll that out into our formations. Our problem with robots, in my opinion, to date is our quest for the aspirational is blinding us to the doable. Okay? Our quest for that. So I am all for aided target recognition. I would love to see a tank that was able to go in cross country and keeping up with an manned M1 tank platoon in the pursuit, but that ain't going to happen anytime soon, in my opinion. I mean, we're a ways away from that. We could absolutely put 4 robots, 2 amphibies, 8 soldiers as a human-machine integrated platoon into a current tank platoon that could carry UAS, that could carry supplies, that could carry batteries, that could carry land-based rockets, that could integrate an active protective system, counter UAS, you know what I'm saying? We could make a lot better tank company today with robots and humans integrated into a formation and tucked back. But that's tanks. The light infantry, which I asked Casey to kind of orient this one on, because I kind of got a vision for that armored human machine integrated platoon, but the light infantry thing's wide open running spaces, and SOF and EOD, things like that. I am relatively certain we're a ways away from pinning a Ranger tab on a robot. You know what I'm saying? I mean, I think Mount Yona, the Yellow River, and a few other things are going to keep us, it's going to be a bit. But shit, man, if we put a rifle platoon into an urban area today, why would we not be able to say, hey, you're last covered in concealed position before you're going to get in a nasty fight? Why can't we sling load or ground deliver a human machine integrated platoon that would let them, because you can run half the route. I mean, almost every robot I've seen you could use in an urban area. Or what if the grade 101st, when they do an air assault and take an objective, if the first package coming in behind that would be a set of human machine integrated formation that could thicken their defense, throw the bubble, right? So we just got to think. We got to think what's doable now, min viable product. So that's what we're going after. One, think big, start small, go fast. So 1 platoon version for heavy, 1 platoon version for the light. As soon as we have something that we're ready to roll out, we're ready to roll it out. So Rob Rash at Richto is the lead for the Army. Ross Kaufman, my deputy, is doing it for me, and General Beagle at Fort Leavenworth's got the rest of DOTMO PFP of this, and Rob Collins, who's Mr. Bush's deputy at ASALT, is going to run the money. So we're going to do different acquisition, different speed, build these formations, prototype them. If you got something, we want to see it. I'm talking like February, March, out of Project Convergence or out of Yuma Gateway. Go that fast. As soon as we can get a minimal viable product, ink one, move it, put it out at the CTCs, give it to the OPFOR at Polk and NTC, let them play around with it, figure out how to fight it, and start piloting it in the back of formations. As fast as we can build them, we're going to start putting them in there, and then we'll expand it out into other branches. But that's where we're at. It's a big idea. It's new. It's different. It takes advantage of this kind of stuff, and I appreciate your guys' interest in that. So that's probably enough for me. How we doing on time? 10 minutes?
Much time is
Okay, I should have asked my aide. How we doing on time? 10 minutes? I'll take a couple questions. Anybody? Yes, in the back. Good to see you.
Hey, sir. Andy Boston, Gary on.
Hey, Andy. 7th first.
With regard to your minimum viable product, it's kind of a two-part question. For both your armor platoon variant, for lack of a better term, and your light platoon variant, what are your priorities for autonomy to support the minimum viable product? And explain to us perhaps your vision on how modular payloads can be interchangeable between these platforms.
Yeah, autonomy is not a requirement for the first ones. I think that's one of the things that's holding us back. You can mitigate a ton of the risk cyber attack and things like that if you can control it. So in a light infantry formation, if I had to do it, if I had to guess, it'll probably be 2 JLTVs or 2 to 4 ISVs manned with controllers, a set of 4 to 6 robots, maybe with surrogates, maybe being able to discharge smaller or carry another set of smaller robots or sensors, probably 8 to 16 people. And they'll be able to control, because right now we're like in the 1 to 2 people to control 1 robot in a meaningful way. We got to invert that, but I'm okay with that for the first couple versions. But I'm the off-road, restricted terrain, all the things that's been slowing us down, I don't think those will be capabilities in the first 1, 2, 3 worth of min viable products. The configurable payload thing, that's to me, that's a critical aspect, and thanks for asking that. So what I would like to do is own a set of standards, right? So everybody know what the Picatinny rail is? You familiar with that? It's the greatest thing ever. When Sean and I were majors, the lieutenant colonels, everybody started showing up with all this good kit, and you had to figure out how to 100 mile an hour, 550 cord it to an M4. And then some genius said, hey, here's a rail. We told all you guys, hey, you want to sell something, make sure it fits. So we need a Picatinny rail for these robots. We got to go out and say it needs to physically attach the following way. 211 Bravo 10s, less than 10 minutes, something like that. There probably needs to be a baseline cyber standard. There needs to be whatever operating system we're going to use. Maybe a common controller, maybe not in the first increment, but as soon as we can get to that, a cyber protect and EW protect. So if I own that standards, we own that, then we should be able to iterate on the robots down, what's carrying it. But the real opportunity is to then create a menu of payloads that anybody who has a good idea that can meet those standards that'll attach to those robots, at this weight, this power. And even that, I don't want to be restrictive on, because whether it's too much power or not is kind of relevant to the capability you're delivering. So that's the idea. And then think, what I see happening in the world, the way the disruption that's happening is we got to get to attritable, low-cost, replaceable stuff, at least part of it. We can't, $1.3 million UAV system, I'm not feeling that a whole lot. I mean, that'll be, we have some deliberate programs. Don't freak out. They're on track, right? But yeah, we got to get it tritable. A company commander's got to get UAVs through the Class 5 system. It's got to show up in a Pelican case from the ammo supply point. Platoon sergeant gets it. I love the lawyers. They're like, well, attritable is this dollar figure. I go, that's ridiculous. I mean, we shoot a Patriot missile, save 1 million lives. It's a great system. They cost like $3.8 million. So why does the dollar figure for a UAV 300? You know what I mean? So Class 5 configurable payloads. Company commander is getting ready to do a mission. Hey, platoon sergeant, go back to the BSA. Give me 2 loads of counter UAS. 2 loads of missiles, right? And then you got a configurable payload. We can continue to iterate with you on the robots, buy them a year or 2 at a time, get a good, healthy competition. Enough predictability, that you can make money, right? The DR that I did on loitering munitions, for example, is new and different. It's a total of 9 BCTs worth, 3 BCTs at a time, which I'm testing to see. I think 9's enough to get the best companies interested. That's enough profit to look at and say that might be worth it. 3 at a time is enough for me to have a little healthy competition. So we would do something like that. Thanks, Andy. Good to see you. Yes?
Sir, you were a former infantryman myself.
Yeah, good.
Working on the ground robotics side, but
Good.
from your perspective, what is the minimum sustainment, right, for specifically ground-based robots? What are we looking at in terms of a on-off perspective? How long?
User operated, user maintained. If you come to me with any kind of tail or requirement, it's probably not I mean, at the light infantry version, maybe some of the bigger built for purpose are going to have some kind of log sustainment capability. But in a light infantry platoon, you know, if it's a common part that breaks, put it in the Pelican box. Give me 4 UAVs. If I need 10 sets of rotors, you know, design it for user operated. Yeah. To include the software. Like they're smart, you know, they're smart enough. One thing I've learned from the software factory and these guys over here, there are smart enough men and women in a rifle platoon. I've been told that in a rifle platoon you can find one person that can do every possible task. Definitely in a rifle company. Steal something, drive something, break something, shoot it, play an instrument. They can, you know, they can figure out the technology stuff. Yeah.
Hey, sir. Colonel Retired Brian Cook, IBM.
Yeah, good to
First
see
of all,
you.
thanks for coming out.
Yeah,
it's always
of
good
course.
to see you at these events. So back up to the strategic level. So
Yep.
the FIDEP, the PALM, the PPB, the challenge of challenges, right?
Yep.
Are you interested in designing and applying AI against those 3 challenges so you can see your bias, your blind shots, and your...
Yeah, a little bit.
I'd love it.
Yeah, yeah. I mean, any use of technology that helps. We could do another meeting on AI. You know, but AI falls into my aspirational versus doable, right? I mean, this is a big problem in our collective. Everybody's trying to figure out what they can't do, but the geniuses are, in my opinion, are the people that can look at 3 or 4 pieces of existing or emerging things and synthesize it, right, and integrate it. So AI might be able to do this, but it could absolutely do this. You know what I mean? And so I'm trying to capitalize those opportunities. I don't think I don't think ChatGPT will ever write commander's intent of an order. Sure as hell not while I'm alive or in uniform. I would fire somebody who said, "Hey, I wrote your intent for you." I'd fire somebody for just doing that 10 years ago. I'd sure as hell would fire them for saying that ChatGPT did it. But think about a running estimate, right? The running estimate, the accumulation of knowable information. Shit. I mean, knowing what I know about staff officers, I think ChatGPT could outperform 50-70% of our majors. so what I'm just saying me, and I'm sure your units were better, but you know what I'm saying? Right? Like what always slows you down is the frickin' engineer's got to go get a calculator out and figure out how many rolls of concertina wire I need to get across the central corridor. I'm like, that shit's absolutely knowable now. So I would be glad to use, and we are doing some stuff up at Carnegie Mellon, try and think different fiscally. It's a great question, though. Yes, sir.
Hey, sir. CB5 retired Corey Anderson. Worked with you a little bit before.
Yeah.
But I've been following along the Project Convergence lanes for quite some time now. And since inception, honestly, when General Kaufman and myself and a few others came together and built that first one back in 2020, we haven't seen much transition out of those.
Yeah.
And the same with the edge capabilities out of FVL. You know, they go to the annual events, and we're just not seeing a whole lot of traction in getting those into soldiers' hands.
Yep.
And a lot of it dies on the vine inside of the S&T organizations within the government, not with our industry partners who are actually able to rapidly do stuff that aren't based on your POM cycle there, because the S&T, you know, they POM for their stuff too. How do we get after that problem and get stuff into the soldiers' hands? Because we're just not seeing it happen.
Yeah, it falls in that inside 2-year rapid acquisition stuff. I was out at Edge. I mean, if you're talking about the UAVs and stuff they have out there, those things are going to be irrelevant in 2 years. So if you can't put them into a formation, so it's not really S&T. I don't even think it's really RDT&E other than maybe some integration dollars. You know, talk's cheap, so I'm not going to tell you I'm going to fix it until I fix it, but I'm working real hard on it. I think if you look at the directed requirements that we've cranked out, that's my vehicle by which to do it. It's really a fiscal money. It's not an amount of money. It's agility of money problem. But we can't win that argument until we actually have a no-shit requirement. So look at the loitering munition requirement and look at the make sure I'm not lying, is the company UAS system one out yet?
Science or something being out as a requirement doesn't mean it's out as a proposal to industry.
All right, whatever. That's kind of shit. I'll work through that. But anyways, company, so we put out loitering munition, company UAS, no promises, but I would predict you'll see one for ground-based rockets, ground-based missiles, and you can visualize. This is stuff that is all exists and is doable. A good counter UAS system, formation-based, not protect this vehicle, but something you can put into, think a rifle company or an AOB, or if you were going to go build a FARP, you could sling in and protect the FARP for an hour or two, those kind of things. So I think those DRs will create a no-shit requirement, and then as industry comes together, it'll be up to me to move the money to match it. But I think that's the key.
Is it still going to go through the PEO acquisition process? Because what we find is transition agreements don't really hold any weight. There you go. It's more or less like at the time the acquisition count takes over and they kind of go different routes.
I don't know. I don't like big, broad generalizations, I mean, like, acquisitions this or AFC, everybody's better, at some things. There are absolutely POs, PMs that are crushing it and that are doing it, and some aren't. I don't know if that's a system thing or a leadership and sense of purpose thing, but I've not had a lot of problems with acquisition people. When you unpack it, it's a lot of times it's testing that takes too long and contracting. Again, great contracting professionals, but they're not. There's not enough. You know what I mean? Like we should have where Indiana Jones warehouse full of people banging out contracts. And that's not how it is. So there's a lot of sad stories and excuses, but I wouldn't pin it on acquisition or transition or anything. It's the whole team together needs to close the acquisition kill chain faster. But if we have something that we want that soldiers need, then I'll make sure it doesn't sit somewhere for a long time. I mean, that's really the only value I add. I'm not the tech guy for sure. Yeah, please.
Yes, sir. Jason Davis.
Hey, Jason.
What additional authorities or coordination do you think you need for the next round of DRs?
No authorities. I mean, we got all the authorities. Between Mr. Bush and I and the chief and the secretary, I don't think we lack for authorities. I don't know. I mean, that's a great question. I hope that the coordination on the writing of the DR requirement is kind of the gold standard. I mean, we just invited everybody that had equity stake, I called John Baraga, like, hey, don't do this by yourself. I called the guys at Benning, don't do this by yourself. Got all the right PMs and PEOs, put everybody in a room and said, all right, this is what I want, write this. Then we staffed it out to not to the world, but to people that know how to fight, and said, yeah, this would be, what I'm looking for is the best infantry battalion commander in the Army to say, if I had this would be awesome. And it would be worth the weight, the cost, the time, the train up. And if that kind of coordination can happen and we can move at that speed, then I think we'll be relevant. Thanks. All right, I'll take one more before I go. Yeah, sir.
Go right. I got a big mouth. Chuck McGraw, former Stoneworks. First, I'll start with the problem statement. I think there's a disconnect between DoD and government in the vendor side, especially on the startup side of the house. We talk about price points for product. And I think what DoD doesn't understand is they want innovative tech. They want to do the tranche, 3-year, you talk about 3 BCT. So I'll give you a scenario. Say we take $10 million of NRE funding. We use about $25 million of IRAD to develop a product that's only going to be able sold for 3 years. So you're looking at about $35 million, but our IRAD is about $25 million. 700 systems for 3 BCTs. Just to recoup and break even of our IRAD, you're looking at 40K. Say the cost of goods sold is about 60K. Now you're looking at a drone that costs $100,000 with no break even.
And if we don't win the program, because the cost of acquisition, working with the program office takes 2 to 3 years, 2 years to do it, a year of just negotiations. And now the government's like, I want that for $15,000. And innovative startup companies, we can't do that. We will absolutely lose everything we have because we have to be a dual-use technology. So maybe a question to follow up on, but how is DoD bridging that gap to understand what is the business side of working in innovative tech startups? Because it's like they have a champagne appetite with a Bud Light budget. Well, maybe not Bud Light, but maybe another Coors Light, PBR.
I'm not touching that one. Nice try. Yeah. One, I feel your pain. I'm aware of the problem. DIU, Strategic Capital, AAL, SIBR. I mean, none of them are the answer, but I think those are indicative of the fact that the department and the Army understand this is a problem and are trying to figure it out. So I think we need to stick together to keep working on it. I don't want to lose the small innovative businesses. What I say, you gave a great example, so that probably ain't the program for your company. But software is fascinating because in software there isn't all that. You know what I mean? It's two people with a great idea and the right skills can compete with anybody. They can get after it. So maybe I got to figure out how to write requirements that create opportunities for smaller companies to contribute to a larger requirement. You know what I mean? But the sky's the limit. I'm telling you, the UAS requirement just think off the top of your head what different payloads you would put if you had a good attritable UAS. I mean, just think about that. And I can only think of like 8 or 10. And if we brainstormed it on a whiteboard up here, we'd be at 30 in about a minute. The problem is all that innovation, like everybody's trying to sell an EW capability on a UAV, for example, right? But they're all building it on their own UAV. You know what I mean? It's killing me. So I want to say, like, hey, for the next 24, 36 months, here's the UAS we're using at company level. Here's the configuration. And I'll take an EW, an IR. I need network extension. I'd like to be able to drop something from it. I can just go on and on and on and on with those capabilities. So, all right, I'm the least interesting person and least knowledgeable person in this forum. So I'm going to get off the stage and let you get back to work, hang out with my experts. Dr. Shadowski's our head robot guy. But buy into this human-machine integrated formation thing, attritable, lower cost, configurable payloads, min-viable product, right? Think big, start small, go fast. And I look forward to working with all of you. Thank you very much.
Can you all hear me? Yes, I managed to work the microphone. All right, welcome to VERTEX, and thank you so much for being here. We are so excited that all of you are here with us for the next 2 days. I want to extend a special thanks to General Rainey for being here. As commander of Army Futures Command, there's no more important authority on what the Army needs and will build. His vision is central to everything that we're going to do here today and tomorrow, and I'm so glad you got to hear it from his mouth and ask him questions. Now, the idea behind VERTEX is pretty simple. Army leaders need to solve technology problems, and we want to have them meet face to face with the innovators who can solve them. That sounds pretty simple, right? But it wasn't always this way. For a business that doesn't have a lot of experience working with the Army or the DoD, it can be a maze with no entry points. And if you have a game-changing technology, who do you talk to? How does your business know how to align your timelines to the Army's budget cycle, which you heard General Rainey talk about, so that you can be confident that the funds are there to support your development efforts, and then ultimately, to your point, sir, where you make the money on the ultimate procurement contract. That's a huge problem for companies, but it's also a huge problem for Army stakeholders who need commercial partners to solve priority technology gaps. One of the reasons that Army Futures Command was created and why AFC created the Army Applications Laboratory was to fix the things that kept the Army and industry from working together and to try to reunite commercial technology with national defense, the same partnership that created Silicon Valley. So we at AAL came up with a pretty straightforward proposition. What if we put supply and demand in the same room for a couple of days and let them get to know each other? And we did. This is our third VERTEX in the theories, and the results have been promising. Previous VERTEX events have paired innovators at the cutting edge of science with soldiers who write the concepts about the future of war. And ideally, those conversations shape the requirements documents that General Rainey mentioned to ensure the Army develops the right technology and ultimately allows the Army to purchase that technology at scale. Bringing together problem owners and problem solvers like this can even result in solicitations that puts folks like you to work in the near term, building solutions for soldiers. VERTEX is one part of this broader effort to make all of that happen, and it ultimately can lead to technology that gives America and our allies clear overmatch on the battlefield that won't just win, but hopefully prevent wars. I'm hoping all of you will become partners with AAL and the Army over the long term, bringing us your problems and your technology, and working with us to create solutions. I'm here during the event with Tony and the rest of the AAL team to talk to you about AAL and how we can help bring the Army and industry together in a framework that's returning great results. And because I'm going to say this, I'm going to steal General Rainey's line, I really am the least interesting person here. I'm going to get off this stage so we can get more people up here that have conversations you want to hear, and let's get to work together. Thank you so much.
All right, I think we've got some panel we're putting together. Panel's ready to go over here. All right, so first panel out is the unscrewed systems for maximum performance and efficiency. I've got Mahdi Al-Husseini is going to be my moderator. He's an aeromedical evacuations officer in the 25th ID, apparently. Then we've got three executives, C-suite folks, to help us out, too, as speakers. CTO of Edge Autonomy, Alan Gardner. CEO of Primordial Labs, Lee Reitholtz, and chairman of the Robotics, Inc., Chris Tucker. So if you guys would just please come on up here. It's pretty informal. Mahdi, moderate this. Don't let them fight amongst each other. You're smart enough to do that. And you guys tell us what you really think. That'll be helpful today. Thank you.
The intelligent, check, can y'all hear me? Check, how about this? All right, I'm gonna go and drive on without the mic. Can everybody hear me okay? Yeah. All right, perfect. The intelligent integration of man and machine has enabled significant improvements in performance and efficiency, reductions in operator cognitive load, and increases in transparency, thank you very much, in our operations. Recent advancements in computer science and robotics have resulted in evolving applications in human-computer interaction and human autonomous teaming, especially in the defense sector. However, how we integrate manned and unmanned agents is not trivial. There are technical, training, tactical, and even philosophical challenges that we have to navigate. Good morning and welcome to the first panel of VERTEX titled The Integration of Uncrewed Systems and People for Performance and Efficiency. Check. All right, that's a little bit better. I'm Captain Mahdi Al-Husseini, the moderator for this first panel the Director of Modernization at the 25th Infantry Division and a graduate student at Stanford University studying human autonomous teaming. Today, we're privileged to welcome 3 experts in the field of human-computer action. They include Alan Gardner, CTO of Edge Autonomy, Lee Ritholtz, the CEO of Primordial Labs, and Christopher Tucker, CEO and Chairman of Geo Robotics. This will be a 45-minute panel with time on the back end for audience questions. So with that, we'll go ahead and get started. So to begin, if you don't mind, Alan, if you'd introduce yourselves, and then we'll go down the line.
Yeah, mic check. Sounds like we got it. Alan Gardner, I'm the CTO of Edge Autonomy. We make Group 2 unmanned air systems with support right now to USASOC, MARSOC, lots of SOCOM, FBI, DIA, and others. I've spent at least 20 years in the unmanned vehicle space, from Group 5 UAS, a large, sophisticated aircraft, down to the small, really kind of small aircraft as well. But that's the focus of my work, is the unmanned vehicle space.
Lee Ritholtz, CEO and co-founder of Primordial Labs. What we're focused on is making robotic systems easier to use. And the way we're doing that is through an AI assistant we're building called Anura. And fundamentally, Anura is composed of 2 pieces. There's a conversational front end that allows operators to speak to the robot naturally, like they're talking to a human teammate. And there's also a platform-agnostic autonomy engine that's on a number of platforms I'll talk about throughout the course of the panel. But those together make the system much more easier to collaborate with for humans.
Great. I'm Chris Tucker. I've been hanging around the Army for a couple decades, but came in through the intelligence community to the national security space by as founding chief strategy officer of InQtel, the CIA's venture capital fund. And back then, I kind of realized that everything on Earth exists in space and time. Literally, right? The Earth is this geographic ellipsoid that if you want to be able to operate on top of it, you need to operate with geographic precision and accuracy. And invested heavily in the Open Geospatial Consortium, which the DoD has been involved in for the past 3 decades. But most people think of it as maps and imagery. Robotics is the implementation of the Open Geospatial Consortium's sensor web enablement architecture, soon to be replaced with what's called the Connected Systems API. We built Open Sensor Hub as a open source API implementing that architecture that you can plug any sensor thing, robot, whatever into. And then GeoRobotics is the commercial SaaS implementation of that architecture. Thanks for having me.
Thank you, gentlemen. So Lee, we'll begin with you. So we mentioned human-computer interaction, human autonomous teaming. These are big fields with a diversity of applications, and they exist at the cross-section of multiple technical subspecialties. So what are some of the key considerations or subcomponents of these overall fields that we can look at that we should be aware of?
Well, I like to think of it in terms of 3 buckets. There are the platforms, that's the aircraft, for example, and all the sensors on board. There's the autonomy software, and then there's the human-machine interface, the collaboration interfaces. And so that's how we think about it. And like I mentioned, at Primordial Labs, what we're focused on is as these aircraft and as these autonomy stacks become much more capable, they end up becoming less like tools and more like teammates. And so the way we think about it is that we're providing a capability that allows operators to interface with these robots like they interface with human teammates.
So autonomy, collaborative interfaces, and platforms. So maybe beginning with autonomy, Alan, what are some of the requirements that we should have in mind to ensure that the autonomous systems we put out on the battlefield are both practical and predictable? Are there any kind of key limitations there? And do you have an example or 2 from Edge Autonomy or otherwise?
Yeah, I think capturing the limitations of autonomy is kind of a critical thing. And General Rainey mentioned that, and I love what he said. He said that we have to leverage the strengths of computers and humans and use those to mitigate each other's weaknesses, but to focus on having humans do things that computers will never do. And I don't know if everyone else caught that. That was a really bold statement, that computers will never do. And I want to highlight that because there are, in our view, key limitations of autonomy and what you can do with computers. And it goes back to Paul Fitts in 1951 wrote the seminal paper on how you functionally break down what computers are good at, what machines are good at, and what humans are good at. And that's been the most cited paper for the last 70 years when it comes down to functional breakdown of computers and humans. That really forms our thinking at our company and how we decompose problems. And when it comes down to where the rubber meets the road, when you're writing code, if you're writing code assuming that computers are simply a superior version of a human brain and can do everything, it's going to guide you down a naive path and solve problems that work in isolated cases or in the lab, but fundamentally break down in the real world. And so you have to capture those limitations. And the way we do that is we decompose problems really into optimization problems that are either single objective or they're multi-objective. If they are single objective problems, then they are solvable by a machine operating alone. If they are multi-objective problems, then you have to bring in the human to do what General Rainey suggested, which was that value-based decision-making in incredibly complex environments. That's what humans are really good at, and that gets manifest in the form of multi-objective problems where you're dealing with competing objectives and how to solve them.
Thank you. And that kind of brings to mind, I think there's a common saying that machines are for answers and then humans are for questions. So kind of with that in mind, Chris, what are the limits maybe of autonomy, right? How much autonomy should we provide, maybe on a mission-to-mission basis, to these uncrewed systems? Or alternatively, how much control should the human operators kind of maintain over the overall interaction?
Sure. Well, I mean, I think we all recognize that there's actually been some really great headway made on this just with simple things. And I like the whole, think big, start small, move fast. Part of what's occurred is, I don't necessarily have to have my thumbs on the joystick to fly the drone in the wind because it now has kind of stabilization built in, stabilization intelligence, right? And I mean, I don't know if you remember the old drone operators back in the day, the wind comes in, it's like, and talk about cognitive, overmatch right there just to stabilize your drone. So I think there's a lot of simple building blocks that have made their way into ROS and ArduPilot, and many proprietary implementations that we can string together and do a lot of amazing things that take it off the operator so the operator can think about the operation. So the basic building blocks like lead the convoy by 500 feet at 200 feet, right? If there's a GPS, if there's telemetry streaming from the convoy, the operator doesn't have to deal with that. It becomes more of an orchestration or a conversation with your drones because you have a set of basic building blocks in the world of autonomy. Then if you don't have those basic building blocks, you never have these higher order kind of reasoning and thought. So I think there's a lot of that. What there isn't, in kind of the world we like to live in, is interoperability across all these different logics, right? Whether you're using ROS or ArduPilot or your own proprietary thing, I need to be able to have a conversation with them, send orders in a way that understands space and time in a rigorous fashion. And then you can start doing more things. So I would say start simple, and we have. But what we haven't done is put out an architecture that says, hey, vendor A, B, C, D, E, F, G, all the way down the alphabet, you're allowed to play in this if you plug in architecturally this way. And then everybody should be expected to innovate like monsters, within their own AI. There's not going to be a standard for AI. There's going to be innovation within AI. There needs to be a standard in how all the AIs kind of converse with each other. Because if we procure as though it's going to be one monolithic procurement, there will be one winner, and we'll have one. Army does too much of that. DoD does too much of that. That has to be stopped, particularly if you're going to continuously roll out new things every 12 months and 24 months.
Thank you. Another thing General Rainey kind of alluded to is a paradigm shift from maybe this man versus machine ideology to more of a man and machine versus the problem framework. And so I think that kind of begs the question, how do we formulate battlefield problems as problems that are designed in the first place to kind of be tackled and solved by cooperative teams of multiple agents, whether they be manned, unmanned, or both? Alan, I'll have you take that one.
Yeah, I think it's, I highlighted that point about single objective versus multi-objective. And Chris's point about, hey, you can give an aircraft a very specific command, right? Follow the convoy at 500 feet, 200 feet above the ground. That is a single objective optimization problem. perfect for a robot. But then you get into things that are more complicated. And when we're building aircraft, we have the single objective ones, keep wings level, maintain airspeed, right? Or even give me a flight path that gets into an area and maximizes time on station, all single objective. But the real world consists of numerous multi-objective problems, and we as humans, these are intuitive for us. We solve these all the time. We go buy houses, and we consider a million different variables, from shag carpet to marble flooring, and how far you are from a 7-Eleven or close to barbecue, and how big the house is. All these things, our human brains are suited to solving those kinds of problems. And the real world is made up of those. So how do you take a multi-objective problem? Let's say I want to create a flight path that maximizes sensor coverage, but also minimizes probability of detection. Well, now I have two competing objectives. How do I now ask a computer to come up with a value decision in that environment? You kind of can't, I would argue. And so what you do is you have to have the computer generate all the options on that spectrum, from I want to maximize sensor collection, I want to minimize risks, those two endpoints, and all the options in between. And a computer can generate all those options, and then the human comes in and makes the value decision about where they want to be on that curve. That is how we approach that particular problem.
So moving now from autonomy to collaborative interfacing. Lee, I think this is probably very much within the realm of Primordial Labs. So what is the state of collaborative interface research and development today, from your perspective? And you alluded to Anura. So how has that kind of helped, as an AI tactical assistant, push the mantle forward in collaborative interfacing?
Well, one big area is trust. And so when you have a system that does something, it needs to do it every time. It needs to do it reliably. And so, along the lines of these conversations about a single objective, you send an airplane out to do something, but then things emerge. The environment is, probabilistic, bad things happen, and it becomes a multi-objective optimization problem very quickly, right? And so, one big part of that is, how does the system communicate back, the issues? How does it communicate back what it's thinking, what it's seeing? And that, there's a lot that goes into that, but a lot of it comes down to how you architect your system, what models, what types of algorithms you're using that are able to be explainable and reportable and interpretable by humans. And so I think that that's a big area of research in general. It's a big area of research for us. And so, that's the answer.
Thanks. There's been a lot of talk about wanting, so I think there was mention about, maybe the distaste of the word robots, right? And so we're looking for more than just maybe a myopic rock pusher, right? We want an actual collaborative teammate for our warfighters. So on the teaming side, Alan, how does the collaborative interface design enable, let's say, an uncrewed system to be more than just a rock pusher, or more than just kind of a myopic thinker, and to actually becoming a collaborative teammate for those warfighters?
Well, I think one of the critical aspects is we have to get away from having unique equipment to interface with these robots. As Chris was mentioning, right? Like you control UAV by some unique interface, and it used to be that you're controlling the actual flight controls, and now it's adapted to now a ground control station that still has all these unique features and unique training, right? That has to get eliminated. Right. And we have to do what Lee is suggesting is, how do you interact with these platforms as if you're interacting with just another teammate, which means you're using the same equipment, the same interfaces, the same software that you use to interface with your human counterpart. And so that means, in the case of, if an operator team uses voice comms, then that robot needs to be able to interface through voice comms. If the operator team uses ATAC and has an ATAC display, and they really interact and utilize that map display, then the platform needs to be on that same system and be able to interface in the same way. So it's eliminating unique robotic interface hardware and equipment and replacing that with the same interface that they use for humans.
Thank you. So the third category, moving from autonomy and collaborative interfacing, are the platforms. And so the bedrock of maybe any intelligent system is the platform it uses to intake, process, and then distribute information in space and time, as you've said, Chris. And so what are some of the challenges that you've seen in georobotics or in maybe some other experiences with developing these distributed information systems that can categorize data on the battlefield?
Yeah, I mean, it's really a lack of an architecture. And I mean, every vendor has their own architecture, right? But when I'm an enterprise and I know that I'm going to be buying this specialized UGV for that, and these, 4 different sets of UASs for various things that they're really great at, the question is, how do I have all of that talk? And, while many of us kind of strive to have our vendor architecture be the architecture of our customer, I think that's a bit naive when it's something as big as the U.S. Army that's trying to automate across all warfighting functions, right? So, I've lived for a long time in kind of the interoperability space where the government's participated, and there's actually an architecture out there, the OGC sensor web architecture, that was really pre-autonomy. And I think you can learn a lot of lessons when it's like, how do I task that satellite? How do I task that pan, tilt, zoom camera? How do I use that laser rangefinder to slew and queue, 4 or 5 other sensors to do with no autonomy? And then you go, this is boring and tiresome and hard. Where can I plug autonomy in where I still have the same user alerts, right, and notifications? Because in the end, as General Rainey said, right, it's not just autonomy run amok on the battlefield. It's got to be teaming, and a lot of that is notification of things that are going on, whether insights that are garnered by that particular platform because of all the great sensors that it has, or objects that are detected or targets that are characterized. I need to be alerted about that. I need to be given, updates on change, and then I need to be given courses of action, right, that are maybe based on multiple goals that I'm optimizing against. And there are architectures for that, but the Army doesn't buy based on those architectures. It's they'll actually go invent their own and pay somebody a lot to kind of, because the Army's so big. But I find that terribly unconvincing and kind of a failed approach to wickering all of this stuff together in a meaningful way.
So I think there's been a lot of talk about maybe the concerns regarding the number of platforms and architectures available. What about some of the upside potentially that you've seen in the industry, right, with regards to platform availability? How have the number of platforms changed in a positive manner, perhaps, in terms of the innovation community? And I know you mentioned georobotics being a cloud SaaS implementation of Open Sensor Hub. A second question for you, Chris, is what are some of the values that you've seen open source software provide the defense community through your work at georobotics?
Yeah, sure. I mean, any vendor, when you ask them about kind of their software strategy for their autonomy play, they'll have different opinions. And I think there's a lot of great opinions out there. You'll see folks that have committed to using ROS for a bunch of reasons. Or they say, I don't like ROS because it lacks real time, and then you get ROS-M out of the Army. Or I don't like that because I'm going to use ArduPilot because I'm wickering together UUVs and USVs with my UGV. Okay. And I think what's amazing is the power of those various kind of core open source things that have been out there, and then the power of commercial companies to say, I'm not going to use that, but I am going to take a lot of the concepts and the modules and repackage it in a upgunned commercial package, right? And I think that's great. I think open source really lays the seeds for innovation and provides an open platform that grad students and all these people that you want to hire, they can be like, I know ROS, I know ArduPilot, and go hired. Here's what we're doing over in our cool, innovative company. So I think that's been amazing, and I think that's great. So you need to have an architecture that doesn't necessarily have to be a slave to ROS or a slave to ArduPilot, but it interoperates with all of that and can put in all these commercial platforms. But it's still got to have a level of interoperability that doesn't say, well, those guys are innovative on that thing, so now, well, let's give them all the marbles. Because 24 months from now, that vendor may be out of business, or that vendor may not have the coolest, bestest widget, and you need to be able to roll them in, as General Rainey said, every 24 months I'm going to be re-equipping. I may actually send them all over the horizon, and they all blow up. So what do I buy next 18 months later, right? I mean, I think that's what the Ukrainians have been learning. They're all expendables, and I send them all out They're all blown up. What's the next 450 units I buy? And they're calling every vendor and maxing out their acquisitions, right? And you have to have an architecture. That's the one thing that Ukrainians, they're doing amazing things, but they don't actually have an architecture for wickering it all together. They just have built amazing workflows on the battlefield that I think, frankly, we can learn from. But plug that into the larger architecture, shit gets real really fast.
Thanks, Chris. I want to transition to two concepts that underpin any intelligence system, and we discussed them briefly. So one is risk, and the other is uncertainty. And you could even potentially see them as two sides of the same coin. And so I think in the manned machining space, two forms of uncertainty we see pretty often are interaction uncertainty between the manned and the unmanned agent, and then environmental uncertainty, given how complex and disordered and chaotic that battlefield is. So Lee, how do we optimize decision-making in man-machine teams given the various forms of uncertainty that we are having to deal with in a world that is quickly becoming more and more uncertain? And as a follow-up to that, how can we in the defense sector become more comfortable working with uncertainty and potentially even embrace it?
I think one good place to start is following on the conversation about standards. Things like AutoPilot and just open autopilot standards and protocols like MAVLink are good things, but I don't think it goes far enough. Mm-hmm. And there's been a lot of conversation about generating synthetic worlds, building synthetic worlds that agents can learn in, and I think that's a good start. And there needs to be more work in these synthetic worlds that are accessible for all vendors. But I think it also applies to the platform models too, and that's where I think there has been maybe some resistance from people who build platforms. But it's important, and I think that it needs to happen to avoid vendor lock in kind of a different way, right? Where the only people that can learn to control their platforms in this phenomenal synthetic world are the people that build that platform, and they own all the CAD models and all the high fidelity system models. And so I would say the answer is really more standards, and when the government buys platforms, there's a requirement to comply and deliver a model that meets a certain standard, so that independent autonomy companies can learn to control that platform. And I think that's where I would go, and how I would answer that is it starts with building up a high fidelity synthetic environment to learn in, and then making platform developers deliver models that are open so that anybody in the community can learn to control them.
Thanks, Lee. And then risk. So you've mentioned multi-objective optimization, right, and some of the complexities involved with dealing with those kind of challenges. So there's a variety of ways that we quantify and we assess risk, right, and there's a multiple risk metrics. So how has, for example, maybe edge autonomy gone through various risk metric assessments and tried to prioritize one over the other? And how much does the mission in consideration basically affect that?
Yeah, it's a great question, and I think this comes back to the point I made a little bit earlier about as humans, we can take something, a simple term like risk, and it means something to us, right? And we can pull a lot of information into that and come up with kind of like this kind of intuitive sense of what that means. But if we're going to now pull computers into the mix, well, we have to quantify it. And in a previous line of work that I did, I was chief architect for special programs at Northrop, and we were building very sophisticated systems. So take, for example, like a low observable system like a B2 or B21 that has to now go into a very severe risk environment, right? What we looked at in those cases was that to quantify risk, we came up with 84 unique risk parameters. So risk was a quantification of 84 unique mathematical terms, all of which were independent and separable. And so how do you now say one of those 84 metrics is more important than another of those 84 metrics? And then how do you use that to actually create a mission, right? It is incredibly complex. And the moment you say, I'm going to have a machine choose the best option, you now have to quantify best. And you do that across 84 different risk metrics. So it becomes this untenable problem that we determined that you fundamentally cannot come up with a best. You have to bring in very good judgment from a human, and you use the human-machine interface that the machine is suggesting options, and then the human is exercising judgment and looking at that and saying, well, what about this? What about this? Can we move it in this direction? And eventually you arrive at what you would consider to be a very good solution. You can solve the problem with absolute constraints. You can say, okay, I'm not going to allow any solution where this particular risk metric of the 84 goes above this threshold. But oftentimes what happens is that you end up hitting that threshold specifically because you're trading off from others. And so you have to be careful when you apply those techniques. But it is complicated, and what we ultimately arrived at there was it is an iterative solution where the human has to be presented with clear information so that they can make a value judgment as quickly as possible, and then iterate again and again. And then you can actually resolve a solution within a minute or two if you do that. In most cases, that's a sufficient amount of time, especially if you're doing like a big, long 24-hour type mission and you're trying to come up with one route. That's a couple minutes is okay.
Thanks, Al. I'd like to dial in on the warfighter now. I think we talked extensively on the autonomous side. So the next question is for you, Chris, and it's a bit of a fun one, which is, how would you describe the future MOS of a soldier on a battlefield that is absolutely filled with robots? What requirements, training considerations, and the like need to be considered?
Yeah, I mean, it's great. Great question. Right now, when we're out there in the marketplace, hanging out with Army, I find myself, I do a lot around kind of USASOC, less kind of big Army, more on the USASOC side. And you just end up with these super high-speed tech sergeants, and I have to ask them, like, what's your MOS? Like, how do you even get here? Some of them start out as, like, commo guys, and they master the radios. They're really into the drone thing because they can figure out all the radio stuff. And other folks, come in through SIGINT and then work their way through Intel or GeoInt, and they're using full motion video to extract 3D. But they're all kind of stuck in this same job, which is be the smartest dude in the unit that the gun toters will say, Steve's going to solve this problem for us. And they're all underwater. And I don't mean that as a criticism. Like, they're smart as shit. They know stuff that I'm like, how do you know all these things and wicker it all together? And that's because, in effect, the Army's abandoned them, right? They're just like, you're the guy, figure it out. And there's no MOS to actually do this stuff for these units. So I'm not quite sure. All I can say is more and more the platforms themselves and the software does take things off of their plate, which is good, right? Because you shouldn't give them an infinite amount of technical complexity and just say, Steve, you'll solve this, right? You need to take these things off their plate. But more and more, these guys are the best folks to actually articulate the mission, right? Because they're like, okay, I've got to we're going to go through the IPB process. We're going to have to build a con-op. We have to brief this up. We have to get, somehow make this work with commander's intent. Then we're going to go out with a bunch of technology, with a bunch of dudes, and we're just going to figure this stuff out. And I think increasingly, the mission planning process, right, is going to require a lot more sophistication in what these unmanned systems are capable of doing, so that I can brief that up chain, so I can then do mission rehearsal, so I can do execution. And I better have archived all of that sensor data in a really powerful way for after action. Otherwise, I never actually know what the hell happened, right? So I think it isn't just putting it on the tech sergeant and say figure it out. That's for darn sure. It's got to be something new, and I don't think TRADOC, unless somebody here from TRADOC can tell me otherwise, I don't think TRADOC thought about that at all. And then you've got to recruit for it, you've got to train it, you've got to do the whole .mil PF. I mean, there's a lot going on there, and I'd love to see a sophisticated conversation about that, because I haven't seen it yet.
Well, if I could jump in, I'm biased here, so I didn't want to bring it up. But I mean, a more natural interface for humans where you don't have to be an expert in the system, right?
100%.
I think that's kind of an easy answer, and we talk a lot about reducing the cognitive burden with our interface, and through this common natural language conversational interface. But it's more than that. It's also training, right? Yeah. So that somebody doesn't have to call from memory how to control the 5 or 6 systems. I think, Alan, you were talking about that. It's one interface for lots of systems, and I think that's kind of the key is make it more more human, really, make the interface more human, and make sure that interface can be used across the slew of systems that are in the arsenal. I think that's the answer.
No, I think to piggyback on that, we talked about standards, and if you look back the last several years, standard 4586 emerged as like the standard to interface with unmanned vehicles, and anybody that's worked with 4586 knows, well, nobody implements that the same way. Everyone has a different interpretation. There's a whole slew of private messages that get implemented, and so it just blows up. It's not really a usable standard. And I would argue the reason for that is that we're trying to use that standard to bring autonomy functions down to a ground station. And so now that interface has to handle all this low-level, raw kind of
Which is ridiculous.
Information that's all unique and different, and it just blows up. But the moment you put more kind of autonomy, and I would call that the single objective optimization problems get solved on board, then the interface can be greatly simplified in a way that can be standardized and then humanized. And now that interface is really about how do we present information to a human to make value judgments. Now it's a simpler interface, and you can actually get it homogenized.
I will say, as we struggle with, we're replacing right now, literally right now, like in the next 6 months, it'll be done, the OGC sensor web enablement architecture with the new standard called the OGC API connected systems. Google it. It's a lot of struggling with things like that. I need to be able to show that the interface actually can do those joystick controls if you have to, right? If you think about it from a PACE architecture, what's your primary, what's your alternative, what's your contingency, what's your emergency, I may actually, when all else fails, actually use my joystick. But I need the same architecture to let me say, lead the convoy by 300 yards. I also need to be able to that tasking interface, be able to give it a multi-objective optimization problem where there's an alert before it autonomously goes and executes one of the options, right? Like, sir, here are 3 options of where the current deployment of the current set of devices and sensors and whatever, here's what we know we can do for you mathematically. Pick one. And you also have the option to not pick any of them, right? And I think that's, at least in the near term, that's what man-machine teaming could look like if we have an architecture in place. Because there's no shortage of innovative companies with unbelievably powerful platforms and AI on them and ability to do kind of that mission planning stuff, at least within their own product architecture,
Thanks, gentlemen. So before we move over to audience questions, I'd like to provide each of you maybe 2 minutes, 3 minutes if you'd like, for any kind of closing comments or maybe big picture ideas you want to put out to the audience.
Yeah, I was just thinking about the standards discussion in this. So one of the things that, for me, like I've worked on really large, sophisticated systems. When I was at Northrop, we were spending at least $50 million a year on trying to build onboard autonomy. And when I look into the future, and I say, okay, when did real kind of aviation autonomy emerge? And if I'm like reading the history book 100 years from now, what I see is that's going to emerge, in my view, in the Group 2 UAS space, which is why I joined Edge back in October, because it's small enough that it could be almost attritable, right? It's that size is small enough that it's not the end of the world if you lose it, but we're now at the point where it's big enough that you can now host some pretty serious compute capability. And when you pull in and you can now offload all of these single objective problems onto the vehicle itself, and you can then say, I'm going to now create this team-like interface. That's when we change the battlefield. We've never been able to do that. We haven't had the capability to do that because we had the aircraft that had that kind of compute horsepower. We were never willing to operate at that kind of simplified interface. We never trusted it enough. And so I think we're at a point now where this is really possible, and it's going to be exciting to see.
What I'll say is that these conversations about autonomy are always interesting because there really isn't a definition of autonomy, And so I'm sure in the audience there's a little bit of whiplash depending on where you sit, what you do, whether we're talking about, traditional path planning and using traditional path planners and automation. Are we talking about data-driven, machine learning-based control of a platform? And, really the answer for moving fast in the next few years is probably a combination of all the tools in the toolbox. And so, whenever I hear folks talking, it's always interesting to think about, where are they coming from? Are they building platforms that people are using right now, and they got to think about their autonomy from that perspective? Or are they thinking about sending a little drone into a A2AD bubble and having it make decisions and react to an environment, which, I think very clearly has to be solved through some sort of data-driven machine learning approach to sensor processing and platform control. And so I'm not going to be sitting up here saying we need a definition for autonomy, but it always is funny to just listen to people, and everyone has different backgrounds and where they're coming from, and then imagine what the audience might be thinking, and it's kind of a little bit of whiplash, and it really depends on where you're sitting. So just wanted to say that, that's kind of what was going through my mind up here, and I'm sure I'm seeing people's heads and nods. You're feeling the same thing.
Yeah, I'm a geo guy, right? Geo robotics, first 3 letters of GEO, and I've spent my career doing that. Everything on Earth, by definition, exists in space and time, including all of your autonomous systems and all of the sensors and devices and control systems, everything that feeds them data. And if you're not doing it that way, you're misguided. One of the things in the robotics space, term that you may all know, is simultaneous localization and mapping, SLAM. And it's all over the commercial space. You have SLAM modules that are baked into these. A lot of people say, oh, I'm going to buy this platform, I'm going to slap this sensor on it, and it's going to do that mission. And I go, well, how's it going to orient itself in space and time autonomously when it doesn't have a global map, really, to navigate, or a local map? Inside ROS, it's called the global cost map and the local cost map. And you need to be able to have things that you can upload a high-res 3D map to and let your AI do some fancy things with it. You also need to be able to drop it into a place where there really is no global map and local map, and you're simultaneously localizing where you are and mapping it, and iteratively getting better as you move through that space, whether it's a loitering munition or whether it's a robot dog, I don't care. And SLAM, to me, is kind of the kernel of what would make all of this stuff work, where everything can work together in precision, geospatially precise and accurate ways. And I will say, we talk a lot about UAS and UGVs, but there's UUVs and USVs, and there's autonomous cyber agents. So if we're talking about all domain across space, air, land, sea, cyber, and some people love to throw EW in there as another domain. And if you're doing that, you need to have all of those work across, within common 40 framework, whether they are a sensor, a thing, a robot, a drone, a satellite, a device, a control system, or a platform across any of those domains. That's where we need to be. And weirdly, there's architectures for that. And there's excellent innovators in each of those domains that are all tinkering with that kind of SLAM concept. And I just encourage us to kind of all embrace that and get your geo on.
Yeah. Could I jump on that to highlight that, because I'm in an absolute agreement. And where that applies to us building unmanned aircraft is that when we fly over an area and you have a sensor, right, and you're seeing information and somebody's behind controlling that sensor today, that's very manual. They're looking at saying, oh, there's a bad guy on the north side of this building, right? Right now, we depend on that humans assessing that and then communicating that information to, say, the forward operators. But as we move to try to eliminate that kind of job requirement, so to speak, and say, okay, we want now these teams to interact with the aircraft like it's another member of the team. Well, at some point, somebody's going to look at that imagery and they just want to click. Like, that's the bad guy, right? But if that is not a geo-referenced point,
100%.
then that point of interest goes into the ATAC network,
right?
And now it's showing up on their map display as like the south side of a different building,
right?
And so unless we can solve that and get to precision in the geo, we're probably not going to get to this kind of capability that we all want.
Right.
And so that is one area that we're looking at, and we see that as a critical point in terms of getting autonomy really unleashed, is we have to get to precision on all of our sensing so the latitude, longitude, elevation, time is all within some bound of error.
Even with an APNT scenario.
And it's hard because, you know, it drives what sensors you use on the platform, right? I mean, you're constantly fighting this weight swap battle, you know, but you want to carry certain sensors to do SLAM, right? And so, you know, maybe there's, you know, new work that has to be done in, you know, the mission sensors that are being used, have them used for SLAM and not carrying SLAM-only sensors.
Yeah. And you can solve it with the sensors. I mean, you could solve it almost directly with the sensor, but you can also solve that with post-processing, right? So you can take image frames, you can georeference, you can georectify, you can do all these things based on reference imagery. And so I think, you know, taking all the database that NGA has created over the years and leveraging that and cross-referencing, that helps solve the problem too.
With that, we have time for 2 or 3 audience questions, if you'll raise your hand. Okay, all right, sounds good. Do we have another microphone? Okay. Awesome.
Cowboy hats first.
Sorry, Alan, great to see you again, buddy. This kind of goes more of a question to the government personnel in the room. You heard all 3 panelists up here say, we need these standards. We need these standards. And if you look at a single portfolio today, even within Army Aviation, they have the FAF, they have the Family of Systems Architecture. They're forcing the FACE requirements on things that don't necessarily transition over to what a UGV does. And then, like you said, ROS-M. And then you got your sensor standards like what you were describing for JICD 4.2. You've got the GEL spec for EW. You've got the new one that's coming out of C5ISR, ISA, which kind of lives and dies in that world. Who from the government is going to fix that problem so that industry and everybody in this room have an operating activity that they can get after?
Yeah, I mean, I sent an email to the Pentagon last week with 80% of your list plus another 40%, basically asking the same question. They basically said, nobody's job. It's nobody's job. They go, oh, that guy owns that one in that program, but it's related to UAS. And that guy owns that one, it's related to UG. And I was like, really? Are you kidding me? And the big thing for all of the progress we've made, first in, you know, in all the different kind of online mill code repositories that we have that in theory we all have access to, but it's virtually impossible to get all of our software developers access to all the right things at the right time, is the government doesn't even ask for API documentation for the things that they bought. So they say, we want this integrated. Hey, cool, can you get me API documentation from the thing that you bought $32 million of? And they're like, what? What? Yeah, like, can you just point me to the GitLab repository, like the .mil, you know? Can you show me what the encoding? I'm like, are you kidding me? And so you're talking about, like, you know, open group SOZA plus FACE plus, you know, ISA at IEWS. I mean, I can go down the list, and like, oftentimes it becomes my job because I have to pull in, I have to spend chits. I have to pull in favors. I have to call secretaries. I have to, you know, like, politically appointed secretaries, not the person that like schedules the meeting, right? To like get code access because it's so effing broken. And if you chip away at it, you can make progress on it. So I'd say it's actually the only job the government has is to make those APIs and technical documentation of what, frankly, 9 times out of 10 are just COTS. They're like, oh, it's classified. But bro, it's not classified. I got for ISA, we got told for 4 years that you can't have access to that. And then we got to the right contractor, and he goes, oh, here it is. I was like, 4 years? You know, and so all I'm saying is what we do with Open Sensor Hub and the OGC architecture is actually write drivers against all those. So the one thing I'd say is there's a hierarchy of goodness in standards. Not that some are less good, but this does this, that does that. Don't say, oh, we have many standards for the same thing, because they're actually different. But you need to have something that connects all these connected systems, right? But if you don't have the API for how that system and that vendor did it, you know, software developers can't do magic. They can't read minds. And if you can't get your APIs up on GitLab or something, just quit your job. Literally, quit your job. Stop being the PM for that program because you're not doing your job. Not in a world where there's an expectation for autonomy.
Yeah, I think that's a great point about publishing APIs, because it's also, we want standards, But sometimes you don't need a standard, right? You just need an API. And
Or the standard requires you to have an API to integrate with, you know?
But if you look at, when we interact with a bank, right, there is no standard for how all banks' APIs communicate with their end users. And we're not going through Time Warner Cable to manage all that, right? We're just communicating with our bank. And so, in the past, when data links were low, on big platforms, like when I was working things at Northrop, so like say, like Global Hawk, right? The bandwidth, every message that went between the ground and the aircraft and the sensors went through Northrop Grumman, right? We cracked open every single message, we repacked it, so all those things had to be well understood by the platform provider. But now, in the platforms that I support today, there is none of that. It is just an IP mesh radio network. You have some software on the ground that interfaces with its payload, and all we're doing is just plumbing the IP traffic. We're not cracking open any messages. We don't need to know what that standard is. We don't care. In fact, I would say at least 50 or 60% of the payloads that get integrated onto our platforms, we don't even know that they're even being integrated. We learn about it after the fact. That like, oh yeah, that sensor, that was integrated onto your platform. You didn't even know? Yeah, didn't even know. It just was done by the customer or their hired third party.
I agree with that, but the amount of time and money it takes to pull that off, and then you have the Northrops, the BAEs, the Raytheon, like everybody then has to do that same thing because that level of transparency wasn't given to all those systems. So I agree, like super smart engineers can do heroic things despite the system, and that's where you see DoD success, and we need to lower that bar. We need small companies, innovative companies to be able to plug into a thing and not have to have a massive team that can unpack every technical standard, because Northrops have kind of access to all those programs because Northrop's big and is on all the contracts. Small innovative companies don't, right? You have to be on contract to even get the technical documentation given to you because that's like GFE, right?
And sometimes it does happen. It just happens despite
the system.
I've seen airplanes catch on fire because people are tapping into batteries, and there isn't a good spec for how to integrate a payload onto a system. And so people are taping it on, and it catches on fire. And just like software engineers are not magicians, I just want to put a plug in for AI and machine learning people, and neither are they. And so, whenever we are asked to be on a new airplane, it's break out the ruler, start measuring, building up a system model so we can learn to control it. And so, beyond the APIs, to learn to, to be able to control and talk to an autopilot, if you want autonomy and you don't want to be, vendor locked to the person who's making the platform to provide that autonomy, there has to be system models out there where autonomy developers can access them and learn how to control them at a high enough fidelity.
So we've got time for 2 more questions. I know it's a hot topic, so you could probably talk on this for a while, but it looks like we've got our 2 right here. We'll begin with you, sir.
This has been an amazing systems discussion. I mean, you can hear the experience, the heartache, and the years that have gone into this. So one thing I wanted to follow up, Alan, was something you said, but all of you touched on was, let's take the example of risk assessment. If you're going to make that autonomous, risk assessment is really subjective to each person that's going to evaluate that risk. The only way that you change that subjectivity is by new information and by a feedback. It's almost a human feedback loop with that data. Something that I haven't heard you talk on, but I know you're thinking about, and that is, what have you found is the best human component, the best way to reveal that information to the human from the autonomous loops so that they begin to maybe think differently or see differently? Examples maybe you've got NLP is what you're talking about, but you've got visual feedback, experiential feedback, you've got STEs now that are giving you digital twins that may add to that feedback. What are you seeing as the best way to influence that human the fastest way so that the autonomous information can be garnered, changed, and modified to go a different route?
Yeah, I would say that the experiential feedback and training, there's really no substitute for that. So when we have when we go into A2AD environments, we take an aircraft into those environments, and we need to understand what the risk component is. There's no substitute for just human experience and training and understanding what all the ramifications are. You're not going to eliminate that. You're not going to just have pull somebody straight out of Starbucks in Seattle and say, go make a decision, a value-based decision about how a B-2 is going to survive in China, right? It's just not going to happen. Even though they're a human and they're fundamentally capable of making value-based judgments, they still have to be trained to understand risk. And so we're never going to get away from training humans on how to be value judgers. And that's critical. So you have to make, when you're developing a solution, you have to make an assessment. Okay, how are those end users going to be trained? What do they know? What experience do they have? And what can I assume that they're going to be able to bring to the table when they're making decisions? And then you design the system around that.
And if I could add, as we get better at building AI systems for defense, a lot of, design patterns will emerge in how we architect these systems. And I think we have to, be very cognizant of, what machine learning models we use. For example, I see a lot of people throwing massive black boxes, trying to learn the entire problem end to end with a massive black box. And like a lot of times we'll get asked, what LLM are you using? It's like, well, we're using LLM, we're going to introduce so much surface area to test. It's impossible for us. And so, you need to make good choices in how you're architecting the system and then what machine learning models you're using so that you're able to pulse the system and give, feedback on what the system is thinking, how it's arriving at a decision or at something it's displaying to the user. I think a lot of that comes to architecture, good architecture, design patterns that are captured across the industry and, codified into our TE-V&V process.
I'll just make one pile-on on that. Inside the OGC architecture, at its core is what we call sensor model language, sensor ML. And it's been around for a long time, and the whole premise was how do I treat that as a process? Not just the INSAs, right, the things coming in from the sensor, but then all the processes I'm applying to it, so that when I get an output from that, we call a sensor ML model chain, I can actually have provenance on how did that get arrived at. Now, each individual process chained in there may be a bit of a black box, and I can't tell you, the LLM is hallucinating, right? So maybe the LLM hallucinated, but I can tell you it went through this version of the LLM trained at that moment, and here's what came out of it and got passed to the next process. And, there's other folks out there who have chained models, but it's part of this architecture as a standard that lets you have that and get visibility into what's going on across a very complex processing chain. And with autonomy, when this sensor is tipping that sensor to slew to then feed information to that autonomous platform, which is, if you don't have that somehow captured, then you've got somebody trying to make a risk-based decision, a value-based decision in a risk environment without actually understanding, what came from what system before it got to their ATAC screen, right?
Yeah, and I think you have to look at how do we train people, right? Are we training people to be able to control a robot in a very mechanical thing? Or are we training them in philosophy, in values, in risk assessment, and training them to be able to magnify the strengths of what humans are really good at? Because if we're spending our time saying, here's how you pull a trigger, here's how you control up, down, left, right, we're losing a huge opportunity to train people on how to be good value-based decision makers.
Yeah, agreed.
Our final panel question, gentleman in the black.
I've been doing unmanned systems for 20 plus years, and kind of what I'm hearing, up on the panel here is, I would call it like, scope creep. A lot of this stuff has already been done. Tad McGear, we're coming up on the 25th anniversary of the first transatlantic flight with an Aeroson that they built, him and Andy built in a garage when they were going to Stanford. Loitering munitions, that was ProCirrus 2007, the on-point system. Those guys couldn't get any traction. They couldn't get any buyers. We didn't have any commercial markets. So what I'm seeing, I don't see a Group 1 or Group 2 solutions in unmanned aircraft systems. And I think that we're like going way beyond. The general earlier said, oh, I need something cheaper. But it's hard to build cheaper systems when you don't have an ecosystem like they do in China. We were talking about common controllers. You know, they have, anybody been to China? I know that's controversial, but they have the World Innovation Zone. And there's 5 buildings. They're 31 stories tall. And you go in, and each one has pieces, parts, components. And this is how you get your $3 motor. This is how you get your $3 actuator. We don't have that here. There is no ecosystem. The controller, talked about different systems. I have a underwater system, has the same controller as DJI. Parrot, Skydio, same thing. Put your phone on it, same interface, easy to use. Anybody can use it. Anybody can fly it in 5 minutes. I taught it for 6 years, how to do this. We don't have that. How did DJI get so cheap? Everybody I want the $1,000 drone. How did it get so cheap? The government invested $1 to $1.5 billion into DJI. And that's how you get your $1,000 UAV. You're not gonna, the other gentleman said, oh, you know, it's $40,000, $50,000. We don't, who else are you gonna sell to besides the military for 2 years? How are you gonna recoup your investment? What we're talking about here are aerospace systems. And as far as I could say, when you're trying to do that with a level of autonomy, it's magic. And you cannot do magic on the cheap. $1 million. I live in California, Northern California, Silicon Valley. You're not going to get talent for less than $200,000, $250,000 a year. And so when you say, okay, well, I'm going to get this STTR, SBIR, and I got $1 million too, and I got to spend some money at a university, and I got to hire people. By the time you tool up and get a facility and hire a few people, you're out of money. So, and that and the drone prison thing that we've got with the test facilities, the general mentioned Umistan. I don't know who's been out there. It's out in the middle of nowhere. It's not pleasant. It cost a lot of money to take the show on the road and bring everyone out there, per diem cars, all the rest of that stuff. It's an expensive proposition. Anyway, it was more of a statement of what the problem is. But I think you guys have some good points.
Thank you very much. So on that note, we'll close the first of our panels. We're going to be moving into a 15-minute break. Our next panel will begin at 11:30. If you don't mind, please give a round of applause for all 3 of our panelists here. And then we'll move into a break. Thank you.
Nice job, Captain.
Hey, thanks. I appreciate it. You guys did all the work.
Okay.
Great job. That was fantastic.
Mandy. Okay. How about now? You hear me? You hear me? All right. If we can get back together here, we've got a pretty interesting panel. Dr. Sadowski's coming up. He's going to entertain us as the Army's robotics lead. If you guys could come on back in, we'd appreciate it. Got our next panel coming up here. Let me get my paper here. Talking about. Hold on.
I think we're supposed to green
him,
is
Bob?
on.
Or you want me to?
No, I'm good.
Huh?
I'm good. I'm good.
Good.
I mean, General Rainey introduced me, so that's all. That's all that matters. Yeah, Bob, you answer all the tough questions. Thank you, sir.
All right, that's right. Well, you want to introduce the others, or I can do that?
I know. I'll get the others in a second.
All right,
I just want to make sure we get everybody seated. I got to start my entertainment stand-up routine. Is that it?
A little bit of entertainment. You know,
Okay.
Lunch is next, so it's all yours.
Oh, so the only thing I'm keeping folks from lunch and my 3 esteemed colleagues up here. Okay, so let's go. Again, Dr. Bob Sadowski, I'm the Army's Chief Roboticist. I like to say I have the funnest job in the world. It's also the most challenging job in the world because every couple of years we decide we want to kind of pivot and do things. absolutely enthralled that General Rainey wants to do things with robots in terms of what's the possible. There's a lot of disconnects in terms of how this people understand the system stands up. What he painted was actually a very glorious picture of the fact that, guess what, from a resourcing perspective, the way the Army does things is we submit, I'm making a bet 2 years ahead of time of what I'm going to produce in 5 years. That's usually how the POM cycle works. So I have to submit my best guess for what I need to do 2 years ahead of time. Then it gets eventually rolled into the presidential budget that goes to Congress, and then they'll execute it. So how good, you know, what is it? Yogi Berra said predictions are difficult, especially about the future. Okay, the other piece is, I always like to say, you know, vision without funding is a hallucination. So my job is to try and make the vision that General Rainey has realizable. And I have to do it almost like at a pace that's very uncomfortable in terms of, you know, we're not doing major program of records, for example. We want to do experimentation. And so the biggest challenge I have as an S&T person is my funding allows me to play with one thing. So let's say it's an RCV prototype that I've put a modular mission payload on. I get to only play with that one thing. I can't build a formation. That's not how I'm resourced. And what I'm trying to help do is inform the requirement and integrate those technologies to make sure that my warfighters out there who are on the, and how many requirements writers do we have out there in the audience? I know we have a few. Okay, yeah, they notice they didn't put their hands up because they know you all run to them, okay? So I saw a few hands go up, but you have to understand that's the requirements process. So we work closely with them. I would love to have a free budget to do something beyond just a Pentax and AWE and Edge, technical gateways and things like that, because we know how frustrating it is for you all to bring your kit out, have the soldiers say they really like it, and have it go nowhere. So now we're trying to figure out, how do I speed this up? How do I have an experimental unit set up at Fort Benning, do something up at Grayling, Michigan? How do I get folks at the two CTCs? That's JRTC at, I cannot remember what the new name of that post is, at Fort Irwin, and at what used to be Fort Polk, I think, what are they called? Fort Johnson, right? That's what I wanted to call it. But that is kind of where he's going, and then ultimately get platoon level pieces of kit that are thrown out there. Reinforce what he talked about. End of World War I, everyone had a tank, they had an airplane, they had a radio, right? There was a power that actually learned how to put command and control radios inside their tank formations and also to their close air support with Stuka dive bombers, and actually did something where they masked their armor. We are like that with robotics and autonomous systems. We need to figure out how to integrate these within these human-machine integrated formations, not teams. General Rainey properly likes to say that I have a team of soldiers. I'm never going to have the same sort of team relationship with my robot, not like near term, so please don't try not to say you're making a human-machine team around that. Say, I am doing a human-machine integrated formation, okay? Then the other piece is he wants to do this at scale appropriately. So you're going to hear all sorts of asks out there. And I'm going to give my opening soliloquy because there's going to be an effort with Richto. He mentioned General Rash, he mentioned General Kaufman, and he mentioned General Beagle. Because it's not just me playing with my one robot and saying this is wonderful. I need to figure out how to do the other piece, not me, the enterprise needs to figure out how to do the whole .mil PF, a fancy word that the Army likes to say, everything other than giving you a piece of kit, right? It's my tactics, techniques, procedures, how do I sustain it? We've already looked at do I need to have a robotics MOS, or do I need to have an additional skill identifier? MOS means I have to have structure, I have to have schooling, I have to have a progression path. How about I go to a school to learn how to be a roboticist for my particular formation for that particular piece of kit? So you're going to hear me kind of talk a little bit about this in terms of when we get to modularity and all the cool stuff that you need to do to kind of give you a picture for where we're going. And within this sort of new RASBOT of the 3 stars, which is always fun to have more stars to talk to, is to go back and sit there, and I asked for, and I got, put in there a sort of technical steering group to get after how do we build the industry, academia, professional society sort of standards body to help define what do the APIs need to look like so that we can leverage innovation at scale. So you don't have to think about how to go back and redesign how to talk to the robot. Okay, you don't have to think about what are the different library modules that are potentially ROS1, soon to be ROS2 based for some of the autonomous behaviors, particularly on the ground side. The air side's a little open because Archer Pilot's so good. How do we kind of make sure those are public? One on architecture, one's going to be on robotic control interfaces, another one's going to be on the safety critical parts because we're talking about lethality systems, and for us, safety is important. Safety is actually a key part of your control architecture to talk to the machine, and that actually has to be something that you have to consciously think about. And then the last one's going to be this funky thing called autonomy data processing, which is, geez, have we architected our platforms with no swap to actually be able to collect data so that we can improve the algorithms as the soldier fights these systems? How do I now create the authenticated data repository that I can now have industry come in and leverage with real soldiers fighting systems so they can build up better AI models to mimic what they do, at least initially, do a little reinforcement learning, and how do I go on further? All that standard stuff is absolutely important because if data is the new oil and we're not collecting it appropriately and we don't think about architecting it, at least for these experiments, we're never going to get to the vision of 2035 and 40 that we're trying to get to. So that's a little bit about myself, and I could waste your entire time for an entire hour. However, I am going to go ahead and have each one of our fine panelists introduce themselves.
Mic check. My name is Chris Brown. I'm a senior systems architect at Teledyne FLIR, specifically Teledyne FLIR Defense, which sits over our various UAS, UGS, and integrated detection systems solutions. So many people in the room are probably familiar with our Nano UAS, little 30-gram drone as part of the Soldier-Borne Sensor Program. Likely familiar with our Man Transportable Robotic System Increment 2 robotic program of record. So we've got a vast product portfolio of UAS and UGS, and there are many standards that fall within those various product lines that we are in deep thought on looking to unify. So this will be a great discussion here with this group as we talk about modularity of payloads and as it affects systems and standards. It seems standards is going to be the buzzword of the next 2 days, and if we put out a jar and for every time we said standards we had $1, we could probably stand up this standards working group to solve the problem. Over to you.
Thank you. I'm Kiju Lee, Associate Professor and the Director of Adaptive Robotics and Technology. That makes a good acronym of ART. So I'm the Director of ART Lab at Texas A&M University. I work on swarm robotics and human-robot and human-swarm interfaces. So not necessarily like working on a single robot to human interfaces, but also like how a single person interacts with the swarm, or a small number of humans can interact efficiently with the swarm. So swarm meaning that you might need to actually interact and interface with entire group of swarm, or a subset of swarms, or even individual robots when sometimes you need a one-to-one control. So not only at that level of human swarm interface and developing swarm intelligent algorithms, we're also working on building new types of robots, and we are actually using the commercial robots as well. So we have a group of heterogeneous platforms that needs to talk and interact with each other to perform collectively and collaboratively. So modularity and interfaces plays a critical role, and we know the importance. I do not know that much of the standards, because in academia we often want to excuse ourselves from satisfy all the standards. So we are excused for that one, but it doesn't mean that we can we can ignore from that one. So basically, I will be very happy to learn more about the industry and governments, and then we'll be happy to discuss further.
I'm Dave Rollinson. I'm the CTO of Heavy Robotics. We're a small company from Pittsburgh, Pennsylvania. We make a modular system of hardware and software for making custom robotic systems, basically things for anything outside of a factory, and all the tools you need, hardware and software, to get particularly things like dexterous manipulation into unique things. We've been kind of selling product to help robotics researchers develop for about 6 years now. Actually, Texas A&M is a customer, UT Austin is a customer. But we also are using the platform internally to make custom systems, particularly for things like industrial inspection. Some of those inspection tasks are actually DoD related, but definitely my background is more on the commercial side. So one of my favorite things you just did is you defined the acronym that you used earlier. So there's a lot of acronyms flying by that people like me probably aren't getting today, but I'm here to learn a ton. And yeah, I think to me, one of the recurring themes I've heard today, you mentioned standards. I think standards is actually in service of what people are trying to do is connect A to B, but it's a real pain in the ass, right? It takes a ton of time. Standards are in service of that, one of the tools in service of that. And as a company, that's what we want to enable. We basically want to create a set of tools that enable a broader and broader audience to create the next generation of smart robotic tools. And so modularity is part of that, standards part of that. So here to have fun.
So we'll start getting into the Q&A, and there's a couple things I kind of also, there is actually a joint definition of autonomy, believe it or not. It's a spectrum of automation that is dependent upon the mission profile, things that we talked about, enemy terrain, tactics, things that have to be done. As part of a human-machine team, it's all blah, 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 blah. But I'd like to try to tell folks is that autonomy means everything. Everything from teleoperation, because I'm still sending commands to a system that will then perform that function, all the way to full autonomy. And I like to use the UAS community. Where are my UAS pilots out there from the Army? I know I got one over there, and I know Corey Anderson's around too, is that there are times when you are in the loop, teleoperating it, you're on the loop, so we take off our large UASs, basically sticked, we turn over control. You may be monitoring on the loop while it's doing racetracks, and if you break down comms, that system will be fully autonomous depending on whatever its pace plan or its, oh good, now I got to define place, primary, alternate, contingency, emergency, whatever. Define that in terms of what that pace plan is, return to base. I was going to say RTB, but return to base, degrade gracefully into the ground, so on and so forth. So that's off the loop. And so autonomy really is a spectrum. And when we talk about these systems in terms of robotic systems, I may have fully autonomous aspects of my robotic system on that platform. For example, I may want my 360 SA running all the time, telling me what's going on, or my health and usage and monitoring system running all the time. We're not quite there yet with ChatGPT in terms of being able to infer mission intent. But absolutely, long-term strategy you heard before is I want to be able to yell at my robot like I may have yelled at my driver one or two times in terms of not going a certain way or doing things accordingly. We want to get to basically being able to do a back brief and ultimately an after-action review. I think we're a little bit further away from that than what General Rainey wants us to kind of focus on in terms of how do I get things in the hands of soldiers. But all those things are interconnected because if I appropriately catch the stick commands and I actually see what folks are doing, I can now turn that into a behavior. After that behavior, I can couple that with appropriately collected data to tie that to a tactical mission. And from that tactical mission, I can build up what I call battle drills, plays to eventually get to a capability that the warfighter is looking at do, whether that means running up a hill doing an LPOP mission or all the way down. And there is no standard for mission decomposition that I know of yet, so this will be a journey for all of us. In fact, we're actually trying to figure out, even for scene segmentation, do I use what the Audubon did to describe trees and roads and bushes in terms of when I try to do labeling on autonomous data for a tactical environment. But the first thing I want to do is I want to do a history lesson, because I have someone here who I could have said was with iRobot at one point, building PackBots, but then they became Endeavor, and then they became FLIR Endeavor, right? And now you're Teledyne FLIR Endeavor. And so one of the first standards that was out there is we realized after we fielded how many robots? 8,000 robots in Afghanistan and Iraq, that the arm from one would not work on the arm from another. The controller on one would not work on the controller of the other. It really frustrated the warfighter because if they blew up their PackBot, their beloved PackBot, they got a Talon instead. And oh, by the way, it was a different sort of configuration and different training. What have you seen within the sort of development of profiles, interoperability profiles, that's helped you in terms of the robotics, being able to provide robotics capability? Over.
Yeah, so I think, a little history lesson, right? A lot of people are probably familiar with iRobot, little roving vacuum cleaners. But on the defense side of that business back in the day, we had our own software stack, right? Our own proprietary software stack that ran our robots. And I think, at that time, and, maybe others in the industry were doing the same thing, but at that time, that wasn't accepted well by the government, wasn't accepted well by our end users because of some of these interoperability challenges. So one of the key tenets that we adopted when we kind of separated from iRobot and established Endeavor was digging in on interoperability and really kind of taking the cultural paradigm shift of adopting the interoperability profile standard as we developed new platforms. And I'd say that's literally paid off in dividends, right, as the awardees of the Mitters Increment 2 contract and the Chris H. Contract, as well as now the follow-on Enhanced Robotic Payload contract. Right, there's hundreds of millions of dollars that we were awarded by kind of embracing this government standard of IOP. It's not perfect, right? I'll be the first one to tell you. I'm sure several industry partners would tell you that as well. But I think the important thing about IOP is it has evolved, right? And it is a collaboration between government, industry, and academia, right? So sure, it was initially developed for EOD robots, right? The Mitters Increment 2 platform was really the first platform to be fielded as an IOP compliant platform. But it's since evolved to accommodate mission sets for like the SMET platform, right? Carrying around rucksacks and ammo and water. It's embraced some autonomy aspects to tackle some of the RCV type applications, lethality applications, and that. I think the important thing is that industry and government have been collaborating on evolving that standard to align with the CONOPS and requirements of the systems. And it's not just the command and control protocol, right? I mean, IOP is evolving, I think, on the air side with RAS-A and the adoption of MAVLink, but IOP on the ground side is also defining electrical interfaces, mechanical mounting interfaces for payloads. So we as industry, I don't have to assign a team of 4 or 5 mechanical engineers to come up with the next cool new whiz-bang way of attaching a camera to a robot. It's a Picatinny rail, right? To General Rainey's point, Picatinny rail works. The standard defines it. You attach your payload based on that Picatinny rail or the other mechanical interface that's specified in the standard. Electrically speaking, right, the connectors are defined. So you don't have to task an electrical team and a mechanical team to go find the space for, or go find the next new cool connector that'll survive all the environments that the robot needs to survive. That is all kind of already predefined. And sure, there are swap constraints that come with some of those standards and kind of decreed things that you must use. And it's not one size fits all for a 500-pound robot versus a 5-pound robot, but it's a place to start. And if you find something that isn't necessarily compatible with the requirement for whatever size platform you're developing, you can bring it back to the working group and say hey, we need to evaluate a new connector for this new requirement that the Army's getting after. So it's been, I think, very good for our organization. I think it's been very good for the industry. It allows third parties to integrate with our platform without us ever talking to them, right? I've heard of robots, Mitters robots going to other third parties, up to like 4 or 5 years ago, right? And I'd hear that it was going there. I'd wait for the phone call, right? Because I knew who it was going to. I knew he had my contact information. I'd wait for the phone call, wait for the phone call, wait for the phone call. Then I'd get invited to the demo. And I never got a phone call between the time they got the robot and the demo, and they were able to figure it out because the standards were there. And I think there's multiple stories of that kind of same, or multiple occurrences of that same story, where because people have familiarized themselves with the standard, it does kind of facilitate third-party innovation on the platforms.
And that's actually managed by AS4 subpanel on the Society for Automotive Engineers, and they have industry working teams that we're up to version 5, and they're currently working towards version 6. And so just trying to give you a heads up, there are some things out there that it probably, from an Army perspective, we probably need to better make sure industry understands so that they know if they need, there's an API or an ICD to that. So now I'm going to flip it over to more of the commercial space. You talked a little bit about modularity. Why don't you kind of explain a little bit in terms of your modularity and your API strategy?
Yeah. So our part is basically to partly stick to the parts that we're experts, but also stick to areas where we think there's kind of an unfilled need for motion control. But everything about our system, whenever we were making designs architecting it, we're basically designing for ease of configuration and really like hackability. So, our modules click together, but it's not like some sort of like super overspecified interface. It's just like a bolt pattern, right? And you can adapt to that pretty quickly. And the two things that we've kind of come to believe in is basically, and this is real nuts and bolts level, but on our level, it's like take as wide an input voltage range as you can. Just like when we're building inspection systems, we have this one project where like every week, I swear, they give us a different sensor. And it's like, oh, the sensor runs on 19.5 volts. And it's like, can I run it on like a little bit higher, a little bit lower? So it's like, well, no, probably not. And it's like a $25,000 sensor, so you probably shouldn't just mess around with it. But like take wide, and that costs you weeks, right? All of this is like little things that cost your team weeks that really don't need to happen. And the other part of it is we're a big believer in Ethernet. Even though there's a lot of overhead in your module that you carry for that, it really decouples the system, right? In the sense that like your computer can be on board, your computer can be off board, your computer can be, in Pittsburgh while I'm here. Those are the tools that basically let you hack. These are standards, right? Essentially, but they're chosen to basically speed up the development of your team, in terms of getting something in the field and trying it out.
Yeah, and so that's kind of funny. I kind of joke with most roboticists now, if you don't have a good network engineer, you haven't figured out how to be a good on-platform network engineer, you really haven't worked hard enough yet or stressed yourself. The other thing is, how many folks here are doing ground robots? How many folks are doing air robots? All right. How many of you on the ground side wish we had the air only to deal with? That's me, right? Because the air side is so much easier in terms of nice gravity stratified fluid. It behaves well. I can see further in terms of reaction time. The ground is always a little bit more challenging or hard.
You just got to get high enough.
Exactly. So it's really from an academic perspective. How do you see modularity and all these standards things? How do they do they impact you at all? What things do you try to kind of not worry about in terms of getting after information exchange? Kiju.
It impact a lot. So basically, the modularity can impact at the single robot level, like all those. So we put payload of different sensors depending on the applications. If the ground robot is used for the inspection or other applications, it needs specific types of sensors. We do not build our own sensors. We buy commercial and off-the-shelf sensors, and then we integrate them together. And the integration happens at the level that how you can modularize, and then how you can use it and integrate it in the way that could be broken down, and later you can swap it with the different types of sensors. So when it comes to even multi-robots, it's not necessarily, in my perspectives, when you are working on multi-robot systems or swarm robotic systems, when you use different types of robots, even ground vehicles with aerial ones, or different types of ground vehicles, different sizes with different payloads, it's important to actually exponentially increase the capabilities, not necessarily having n number of same robots capable of n times of the individual capabilities. When you have heterogeneous kind of types of robots, then you can expect much higher level of intelligence. That plays the same in human too, right? So we embrace diversity because we expect to create something that is something more than what just the same types of people or same background of people can create. Whenever we work with robots, they are not the same, especially multiple robots, then the modularity and the actual interface plays a critical role, even more complex, more difficult or more critical role than in a single robot system and within the single platform, because they have to communicate with each other, but they are different. You cannot use the same locomotion algorithm for two types of robots that has different size of wheels. One robot may be legged robot, the other one will be wheeled. We're primarily working on wheeled robots, but we recently built a new types of wheels that can do the multi-terrain locomotion, and you can climb over the stairs. If you use open source algorithms and software that is kind of with all the EKF algorithms and those things, when you use it, it works well with the commercial wheeled robots, but it doesn't work well with my robot that can open into the legged configuration. So then, we try to work around that kind of level of errors, but you have to actually end up building your own algorithms for that one. So software modularity and hardware modularity is important. We want to basically to make them to collaborate systematically together. So basically the proper modularity impacts the agility of the development, especially in the academia, in a small like research groups. The actual, the interface and also the modularity makes it much faster or slower if that doesn't work.
So I'm going to give you the software modularity sort of question right there, Dave, and also talk about, you're doing manipulator work, predominantly industrial and academia. What sort of software modularity, open source systems are out there in the industrial space for manipulation robots? And do you play with that at all? Do you understand it? Is it good? Is it bad?
I mean, there's things like ROS and ROS2 and ROS Industrial, and some of our customers do that. That's an option, but it's not the only option, right? We want to provide, again, we want to have flexibility. If you know those tools, you can bring those. We have basically a software stack for doing kind of that lower level control that gives you some options that you don't get in things like ROS. But it's basically pick the tools that you want. It's that. If you're focused more on autonomy, right, that's one thing, but like we're below that level. So like when people say like, do you provide autonomy? And I was like, when you said autonomy, I heard autonomy you. Because we're all the things below that to make that easy, right, is what we're trying to do. Whereas if you're like human in the loop teleoping, there's kind of different tools you might be using that are appropriate. But yeah, our job is to be flexible to allow standards and things that are developing at the higher level be easy.
So as you're developing your sort of modular software stacks, how modular do you get? Because there's different arguments. One is I make it one big black box with one simple API in and out. There's another one in terms of, hey, I can brick it down a little bit more so that I can be a little bit more customizable. What's sort of the strategy that you all have taken in terms of trying to go after that sort of modular approach?
So I'd say like on the device level, we kind of have the assumption that any sort of like widget part of your robot is an Ethernet, has an IP address as a full-on Ethernet device. And then from there up, we kind of, because we've started there. So this whole project actually started with Snake Robots at Carnegie Mellon, and we were like focused on the module. And then every layer we've added to that has basically been like another API on that. So, there are some things where you build, it's cool to build the whole monolithic application, and then sometimes you got to dive under the hood, and it's like you open it up and you're like, ooh, there be dragons. That gets really messy. But for us, like because we've built the way up, you can kind of throw out whatever part of the stack, that we make that you guys don't like. But underneath that is like an actual API, right? That's documented and usable. So I'm very much a believer in doing one thing well, and then try to play nice. That's not popular if you have to be like VC backed and like own the customer and take over the world. But if you're building a technology and trying to get that to thrive in the world, I'm really a believer in a specialized system that plays nice with other people. Even though that's definitely not the trend in like big backed software and stuff like that right now.
So let's go a little bit to modular mission payloads, because that was something that General Rainey kind of poked us a little bit with. And you use the example of the Picatinny rail. I'm sure there's somebody from Picatinny here somewhere. So that's a great example. He walked out. I saw him in here earlier. He won't put his hand up. Okay, got it. The Picatinny rail was an example of a physical thing that enabled you to modularly clip on things. What we have to do in the robotics space is a little bit different. We're talking maybe about a little, not quite 80-20, but basically coming up with something we're going to probably call the Warren pallet. Don't go there. They wanted to call it the Warren rail. And I'm like, it's not a rail because it has to have both electrical, mechanical connections, and I have to make it scalable. So I could have, similar to what you do on a satellite when you're playing with like 1U, 2U, 3U, things are going to pop off a fairing. It's how do I, or a server rack, how do I come up with the sort of physical piece? How do I also come up with the electrical, mechanical piece so it doesn't pop off the robot, but also draws power from the system? And so what would be the type of challenges as I try to design what this next version of the Warren pallet looks like? I'm going to trademark that one. What do I need to be concerned with? And I'm going to each one of the panelists to kind of think through that a little bit.
Size of the payload that is going to attach to it, based on where it could possibly be mounted on a ground platform, and how that's going to affect the center of gravity of the platform is a huge thing. Obviously, if we still maintain, disparate interfaces for mechanical attachment and electrical interfacing to these payloads, what is the proximity to, those electrical interfaces? and can those mechanical interfaces, withstand, robot rollovers, right? They happen, right? And then, is it going to then, be survivable of, those kinds of damaging, tasks and environments. And then there's, our lovely friend, EMI, right? Everybody can design a robot with a bunch of motors and wires and computers and network switches, but making a silent robot from an electromagnetics perspective is its own feat in and of itself, right? So as we talk about programmer record platforms, right? It's all about making them EMI compliant, all about making them cyber compliant. So locking down some of those payload interfaces as well. From a cyber perspective, once you've got those interfaces in place, right? It's not simply just about attaching that Picatinny rail or the Warren rail.
Warren pallet.
Warren
I'm gonna
pallet.
Go with that
sorry.
one. Of different sizes.
Right. It's more than just bolting it down. You've got to kind of think about the whole picture and the end state really of the application.
I will neither confirm nor deny that my inspiration is from a 463L pallet that the Air Force uses to push stuff.
Yeah, it sounded awfully familiar.
Except I want it in multiple sizes to snap in so that I can have small payloads in the back, big in the middle. So what should I not be doing if I'm trying to develop this new modular interface standard? Kiju, any insights? Because you work with academia and you know what and some of the challenges are. What should I not try to make it be?
Sure, I would like to briefly discuss about the hardware modularity, because software modularity, we all understand, we don't understand hardware modularity, but in order to make like a payload configurable, and then you can actually customize the robots using the same like a locomotion system, you can actually make it intelligent for different types of purposes. Hardware modularity plays a significant role. But one part that I wonder is does every system has to be modular? I guess not. Some simple robots, it's better to be fully integrated, and then you don't need to actually open up and then fix or replace or reconfigure, depending on the applications and depending on the target areas. For instance, Army and defense applications, the system must be deployable and then rapidly configurable depending on the rapidly changing environments as well as uncertainties. So I think the modularity in the hardware that allows not engineers, the soldiers actually can replace or maintain those systems is important, and then that's where we can achieve from the modular system in the hardware level. So to get back to the question, so I think it's not every hardware systems or autonomous systems must be modularized. At a certain level, we need a modular structure, but what is the modular and what is the optimal modularization is up to the actual target areas and application specific needs.
All right. I'm going to do the curveball and say that as time has gone on, I think the actual physical mounting, and I'm probably misunderstanding the military altogether here, but the physical mounting isn't nearly as important as how you power it and how you communicate to it, how it works with everything else. Because I spent 5 years inspecting sewers, and the number of times we took really expensive things and mounted them with hose clamps because that was the best thing to do, right? I think those standards are really, really great, but you're going to burn way more engineering time and things integrating on the power and data and communication side and all the things that echo through software. And also I think that one of the big differences even from 10 years ago is the ability to quickly manufacture whatever weird adapter you need properly is a lot easier now than it was 10 years ago with being able to bring, I'm assuming CNC machines, 3D printers, you can bring those further forward way more now than you were before. So I'm way less hung up on mechanical interfaces now than I am on electrical and software interfaces.
And absolutely agree, and it was nice that our Teledyne FLIR area talked about it, because that's actually, people think when I talk about an interoperability profile, that's why I don't like the word Warren rail, because that implies I got to come up with something better than pallet now, right? Electrified pallet, I don't know, e-pallet or something. But the whole purpose is that it's really the network that you're attaching to the power. What is that interface standard? Because then you may have to do special things, particularly if I'm controlling a weapon actuation or something that applying a certain effect, I might have to have a tunneling aspect of it. And so it's really, I have to tunnel those commands in a little bit separately for security reasons. So there's all sorts of hidden truths that are going to be in there. Is this something that you feel that you know, the labs should just sit there and do by themselves?
Probably not.
Okay.
I mean, I think there's some innovation that industry can provide, right? There's lots of smart people out there coming up with new ways to mechanically attach things. That should probably be considered. Not that they need to make it to the top and be the one that rule them all, but it's a problem that industry ends up having to solve as size, weight, and power constraints become a real thing, right? I mean, I mentioned our Black Hornet system, right? Like, you're not putting a Picatinny rail on a Black Hornet; it's going to fall out of the sky. So, clever interfaces are still kind of being developed within the space as we try to, make systems smaller and lighter. And as awesome as the Picatinny rail is, it doesn't fit every application. So there could be, some fancy new whiz-bang, mechanical interface that comes out of industry that, if they were willing to play, right, could be adopted by all and handed over to the government with unlimited rights.
Yeah, I mean, the other piece in terms of the electrified pallet was, guess what, it's a standard size. You just clip on the bottom whatever your footprint is. But when you start talking about heavier systems such as weapon systems, there's impulse functions on the robot, like you said, that could cause it to tip or fail. The other piece, now let's flip that a little bit. So now I've got this modularity that I'm trying to achieve, and we heard a lot of concerns over, software interfaces, particularly from a user perspective, a sort of common controller. The Army originally wrote that into the requirement for the, CRISI, right? The Common Robotic System.
All ground robots?
Yeah, it was, the tactical robot controller. And they realized that's not the right approach. Industry makes some great controllers. Really what they're trying to focus on is the sort of common kernel that merges aerial platforms. This is a program record. You can talk to PMS UAS, they're already doing, or UAS is already doing it. In terms of they're trying to come up with a sort of common kernel for robotic control, so all those safety critical functions that allows us to enable these systems, and then basically have people be able to do appliques on top of that as an approach. I'm just putting that out there so folks understand we are hearing that it's not good to have 55 different interface standards to talk to a robot. How do I merge air and ground so I can do things like such as target custody, handover appropriately? So from trying to figure out how to put this in how to put that. So from a controller perspective, because it's really important to folks understand, I got safety critical systems, I've got the autonomy, we always focus on the autonomy, but there's also this human machine interface that has to be there. And the swap C that I have on some of the platforms we're actually fielding is going to provide great opportunities in terms of, believe it or not, I can't put the smarts on my SBS. Well, I can put a little bit. Where could I put the smarts?
You can put it on the soldier.
On the controller.
Yeah.
Right? So here's opportunities. So how should we do the APIs such that you all can interface with these controllers? I mean, so what does open mean in terms of that? Is it something I have to go to a industry website like a consortium? Is it something that I go to a technical body? Do I make it dist A and just publish it to the world like we do with ROS? What do you think, what would be the right appropriate way to allow the biggest players to or the most players to come in? I'll ask all three of you to answer that. What do you think?
I mean, I think making it so that it's not necessarily pay to play like some standards are that are out there, right? I mean, what incentive does that industry have if they've got to shell out a $25,000 check or whatever to get on board with this consortium to get access to a standard? So definitely making it accessible. Obviously we want to protect our standards from a security standpoint and whatnot. So whether it's something akin to ROS-M and making it accessible that way, or just I think making it accessible to integrators and developers is the key, right? Not just those of us developing platforms that have the requirement that says thou shalt be IOP compliant. It needs to be accessible to outside parties.
Yeah, I would like to echo what Chris just said. basically, like, when from the academic perspectives, it's important to have accessibility to those, like, the commercial products and the sensors or other devices. But often we often have to actually access the actual programming level to customize or develop and then continue on with our research. But it's often into we hit the wall because there's like accessibility issues with those commercial products. So I think it is important to have, like, that maybe, I don't know if that is even possible, but like different standards for like academic and research, because research has to move fast, and we want to kind of innovate and then explore new ideas and investigate, like, the problems. However, sometimes we have to rely on commercial product on many aspects of the robotics research, and those, like, the accessibility and those issues often becomes like, greater kind of, cause of delay in research. So we often have to kind of to go around or try to avoid some of those products that has less accessibility. So we often choose one sensor over the other one because of those issues as well. So I think maybe some level of, like, different types of standard apply to industry or like other, like, consumers, and then researchers might be needed in terms of robotics development to truly expedite the process and also to embrace the actual developing communities.
Yep. And yeah, I think the one of the key things latched onto is developer friendly. Part of that is like if it can be open, free, that's great. But there are definitely like some standards that are like open and out there, but they're so complicated you have to hire like really expensive expertise or pay out the wazoo for consultants, and you pay way more than $25,000 for that. So you can have an open standard that's still effectively not as useful as like a paid thing. So that's kind of a key thing to be aware of. And then one thing you mentioned early on in terms of decisions we make is safety critical stuff and where that lives, right? Like one of the big decisions we make is all the safety critical stuff about the actuators is embedded and runs hard real time in the actuators. That allows that flexibility, at a layer up, and making smart choices as to where things are definitely considerations.
Okay, so now I think it's perfect time to open up for questions, right? We're still doing good on time, correct?
I'm Brian Govey. I was a former Air Force pilot, and I have a startup now called ResCon. Kind of a self-serving question, like a lot of us are going to probably ask, but our ResCon is into low data edge ML to augment low-level control. We feel like the next generation of vehicles need this next generation of control because of the modularity aspect, where you need to be able to learn and adjust in real time. But there's this constant challenge of how can you insert ML into a safety-critical, potentially, system. So what have you guys seen in your experience with kind of adding ML, kind of adding that black box to a safety-critical system, and how do we approach that hurdle?
I can tell you how the testing community, from an Army safety perspective, views it. They want nothing that's non-deterministic, okay, and that's a big challenge. And so one of the things we're actually thinking about doing is, the problem is my best deterministic sensors are LiDARs and radars, and they emit. So maybe that's part of my safety critical architecture, and I allow that commander an option when I get ahead of the FIBA, turn it off. Okay, then there's the risk decision that a commander is making on the platform, understanding the risks associated with it. There is no simple question. We're going to have to work this through in the process, probably do it in the air first, because perception on the ground side, it's hard. The other challenge is now you're in this sort of double-edged sword. Where did you get the data from that you trained your model? Did you pre-train it on Kitty or ImageNet? Has it been poisoned? What DevOps environment did you have to ensure nobody inserted anything into your trained model, from a black box or white box attack perspective? So these are issues we haven't figured out yet, which is why I'm like, hey, let me keep my LiDAR or my radar initially. If nothing else, I put that in my RTOS real-time system. And oh, by the way, whenever an edge case occurs, so the dumb robot doesn't run into something because the perception system failed, I'm automatically catching the edge case, which is the other thing that, we don't have the infrastructure to collect everything all the time. And I don't need 20 hours of motor pool. I need the 4 hours of real training that they're doing, exercising the system. I don't know if there's a good answer to it. I'd be curious.
At our level, we haven't been, I mean, we don't, that doesn't come into our world as much. I will say that, like, in terms of ML and adopting stuff like that, I have sort of like an omnivore's dilemma sort of part of it. It's like use optimization, not too much, mostly gradient descent. There's definitely a big, for us, a big part of it comes in troubleshooting and errors that come up. It's like it's a lot easier to explain to somebody, here's a sensor, here's where it's not going to work, and explain the edge cases as opposed to have it work like magic 99% of the time and then be completely bonkers like 1% of the time. It's like it's easier just to explain to somebody what the limits are than have it be fail in ways that are completely inscrutable.
Try explaining to a commander that your AI hallucinates. I hate that word. It's a bad word. I know that's what we're using, but I mean, it's like, yeah, my soldier's hallucinating, okay? But we're going to have to go down this path. We know that we're going to have to go down this path to get the sort of vision that's out there. It's going to be fits and starts, I would imagine. And it all depends what the system is doing. If it's just an ISR platform, that's wonderful because it's really not doing lethal effects. But when you start talking about coupling it with some sort of perception system with a system that's carrying something that may be able to apply those effects, even though the operator is using good judgment, what if the robot jerks to the right or jerks to the left, and all of a sudden my surface danger zone is now expanded to where it's no longer a safe application? So again, these are things that the journeys out there. We're working with the safety community to just see if they can trust virtual miles. I mean, how many of us take our robot out to the field without simulating it, air or ground? Probably not. Okay, you're fine. Yeah, okay. So there's a lot of simulation that's actually involved out there and trying to make sure we can get reps in simulation particularly for regression testing. And that gets back to the earlier conversation on making sure you have a good model for your system. And then who gets to certify the model of your system in the simulation and framework? Who's going to validate your simulation framework so that our safety communities can trust it? Because remember, they're independent evaluators who want to break your stuff beforehand. Okay, next question. Or are we done?
We're about done. I think we're getting hungry. But we better shut it down.
No one said that. Raise your hand and say, let's go grab some
Yeah.
chow.
Yeah, thank you, Dr. Stadowski. Thank you, guys. Appreciate this.
Please thank the panel who did a great job.
So a couple of administrative items. You guys don't need to come back here after lunch. We've got some AAL folks on all the floors that we're showing that the breakout sessions will be held. So you can just go right to those beginning at 2 o'clock, I believe, right? So you can also scan the back of your name card there, and you'll know where to go if that's actually where you want to go. And then the really fun part this evening at about 3:45, the buses start over here going over to UT about a mile away, where we're going to have the UT robotics folks show us around for kind of a little exposure and happy hour opportunity. So I'll see you guys over there, and have a good lunch.